Hello, everyone. Welcome. My name is Nathan, otherwise known as Old Man Builds. We got an awesome show for you tonight. We have Sean, we have the Benny Factor, and Gerald should be joining us shortly. Guys, what's going on?
Hola.
Hey, great to be here.
Right on. Hey, real quick, just everybody, we got another member, so in the chat you can throw up the emoji that says holes on it now. So have all the fun you want, guys.
I like how you have all the emojis featured on the bottom and the new ones, so you can see. That's funny.
Oh yeah.
What's funny is that the holes are scientific. When I was in the military, they said you can either do electron flow or you can do hole flow.
You can do hole flow.
Hole flow. No joke. And,
wow. Sean,
yeah,
get me into it.
it's oh boy. I
Sounds like a full hole Monty.
The whole Monty.
That's right. So are you ready, Nathan?
We're ready, man. I'm going to pull Ben and I out and go right ahead.
Awesome. Hey, guys, it's great to see you all in the chat. I have a short presentation. Not a lot going on last week. I spent a lot of time researching. So not a lot of time in the lab. So if you remember from last week, I had taken that piece of crystal, the lead glass, and wound it with some wire. And these are some of the screenshots I was able to glean when I was demonstrating it last week. And so this one I thought was pretty fascinating. This is another one. It seems like whenever the ring is formed, it has those swirls that sort of, let's see if you can see them better here. Yeah, Nathan pointed out where they almost look like they're swirling in toward the center. But every time I see the circle, we see these yellow sort of flashes coming out. There's another one. So yeah, it's just it's the artistic side of what we're doing. Pure energy. The artistic side of pure energy. Here's another one that's a real clear, circle's almost perfect. All right, so what am I doing in my lab? For starters, this is the last of the ZVS boards that I'm going to be building. If you recall, I had picked up 4 different designs on YouTube. Some really smart guys. They had designed the circuit boards for these ZVS, certain ZVS functionality. And so credit will go to the Easy Project for You YouTube channel. And this one's designed with the emphasis on radiant energy. So I'm hoping to do some cool radiant energy experiments with this. So if you guys recall, I had wound a polycarbonate sphere and it caught fire. Well, I couldn't save it, so I went back to the drawing board, and instead of using polycarbonate filament on my printer, I'm using a translucent PETG. PETG, yes, that's correct. And hopefully this will have better properties and won't have the breakdown and the susceptibility to crossover arcing. I'm going to go through just a couple of steps into how I set up these sphere coils to epoxy. And so you know my love for thrift store acrylic kitchen items. And so I always find these pictures here to store my screws. Whenever I take apart something, I throw the screws in the same bin. I know you guys probably do things similar. And so, but what I'm looking for is 3 screws that are same dimensions. And what I'm going to use these, as a instrument to center the sphere inside the mold. And so you can see here, I'm prepping the mold for the screws. And so now placing the screws inside the bottom of the mold, you get this equidistance between the sphere and the mold. And so you don't have to worry about the sphere moving to one side or the other and the epoxy coating being smushed. This is one of the ways that I do this. And here, I think it's just a close up. Oh, I see. So the wire here is as thin as a hair, and it's about 12,000 turns of wire. What I sometimes do, and I don't know why I don't do it more, but I go up to a 17 gauge wire and I solder it, and then I start winding it. That way this 17 gauge wire is a lot hardier than the thinner wire. So this is something that I need to write down in my list when I build these things. I thought I would share. All right, so we're ready. I drill the hole at the bottom, and let's see here what that is. And then I'll bend the wire, and voila, I'm ready now to pour in the epoxy once I put the top piece on. So I'll make adjustments. It seems to be leaning to one side, so I'll start to position it. So it's a nice way to position when you're performing your molds. And because these screws are so small, it really doesn't make a difference in the little indentation they'll make inside the epoxy. But it's an inexpensive way to set up your molds. Now, once you pour the epoxy, it's sometimes a bear to take off the PLA. So the hot air gun is your friend. Now, one of the things I wish somebody would have told me is that when you're using a hot air gun, don't worry about the epoxy can take it. I remember when I first started and I thought, oh, I'm going to damage the epoxy, so I got to be careful, and it was just really tough. Here, I just let the heat gun go. It doesn't put a dent in the epoxy. It's a good tip to know. And so here I'm heating up the PLA. That will not come off. It's like welded to it, but with a little bit of heat, that PLA just comes right off. This is a pretty cool heat gun too. It turns off when you put it back in its holder, so it's a little bit more convenient. And so now it's time to I'll use the needle nose pliers and I'll twist it, and then it'll remove the outer layer of the PLA, the annoying PLA. I used a different release agent instead of Vaseline. I found that Vaseline made it more rippled on the outside. Here I'm using a spray silicone. It's used for spraying windows or sliding glass patio doors, and it's a lubricant. So it looks like it's holding a good form. It seems like it's working well. And so there it is. One of the cool things I discovered with this PETG is that when I put the epoxy, the filament disappears. It becomes completely transparent. Oops. Let's see here. Sorry about that. It becomes completely transparent. So all you're seeing is the wires, the turns, 1,000 turns of the goldish colored beautiful copper wire. And I thought that was pretty interesting. I haven't seen this effect in my other filaments. Let's see here. All right, so I shared with you guys my attempts in using 2 aluminum heat sinks to make a variable capacitor. So I 3D printed these hinges that I found on Thingiverse, played around with them. They look like they're going to work for my purposes, and so I'm going to now add them together. Now you can see them on the left. Now it allows me perfectly to adjust. So right now this would be the maximum capacitance, now the minimum capacitance. So I can adjust it now in different grades of capacitance. And so the best measurement I've gotten off of this setup is 2 nanofarads, which is a lot for a variable capacitor. The biggest variable capacitors that I've been able to find on the internet are 1 nanofarad. I'm going to be putting a few more coats of spray enamel And then I'm going to connect the wires, and then I'm going to hook this up to the Tesla coil, and it's going to be my variable capacitor. So very promising. I sort of mulled over this idea for so long, thinking, how am I going to get these guys to stay consistent together? And these hinges seem to be working. Pretty cool. 3D print some hinges and you're ready to continue your project. There's a top view. What's fascinating too about this capacitor is that, and Nathan pointed this out, if you look at Tesla's patents on some of his devices, he uses this very design of an air capacitor. In fact, when you look at the schematic that was written over 120 something years ago, it'll show this exact same pattern. So wow, great minds think alike, I guess. And I had not seen his designs before I put this together, but good catch, Nathan. Another view. I had some interesting brass screws, and so here we go. I can't wait to hook this thing up. How many views can you have of a capacitor? I don't know. All right, so this next small part of the presentation here is regarding Electrets. Now, if you guys remember last week, I had these grandiose plans of electrocuting using those metal spheres and somehow turning another spherical object into an Electret. And following that presentation last week, Brent Jarvis was so kind to let me down easy and said, hey, we need to crawl before we sprint. And so let's shoot for something realistic, and then we'll build on it. And so good idea. He gave me some tips. So I'm going to kind of show you what my setup is, my new setup. But first I want to talk about these materials. So glass here is at the top of this. This is called a triboelectric series. Tribo just is a Greek word for to rub. So it just means when you rub two things together. And so these materials here, as you rub them together, you're either going to have an abundance of protons, which are positively charged, or an abundance of electrons, which are negatively charged. And so glass seems to have a lot of empty places for electrons to join. I'm not going to use the other word, the H word. And then over here, let's see, I thought I had one of these. Here we go. PVC pipe here has a bunch of electrons, excess of electrons. And so I just want to give you an idea of how this is, these materials, how they're graded, and how they can be then used for experiments. Now, one of the things I found in my junk box, which made me happy, was a PWM. And Jarvis was telling me that I need it. So I found this one in my drawer, and look at that. It goes from 100% duty cycle down to 0% duty cycle. And what he recommends is that I connect this to the high voltage generator. And this will give me a little bit more precision control over the thousands of volts that are coming out of those generators. And so I appreciate the tip. Jarvis was kind enough to put together a diagram, walk me through this, and it's an elegant solution. In fact, I want to use it for other projects. All right, this is, it looks so terrible. I sketched this out right before our presentation because I wanted to show you what was going to be going on in the following slides. So here I have a DC motor, and it's turning this drum here. It's an aluminum drum. In fact, it's a plastic drum with aluminum inside and on the outside. And I'm going to put some ground glass inside of it. And then I'm going to connect up here. If you look at the HV, that's for high voltage. I'm only going to connect the positive to the aluminum. And so what's going to happen here is glass is already positively charged, but it still has a few pesky electrons that we can skim off of it so we can make it super positively charged, and then become the catalyst for our electret, because an electret has to be either a strong charge of positive or negative or both. And so this is what my idea was, is that as this rotary drum rotates, the glass is going to be scraping against the aluminum that's charged, as well as aluminum is positively charged. So this is also helpful. And then my hope is to connect a diode to ground. And then as electrons are being picked off and pushed through to ground, the diode is a one-way, like a one-way valve. So the electrons won't be able to come back up and reach equilibrium in here. And so therefore the contents of here is going to get more and more positively charged. And my hope is that Jarvis will say, hey, this is a good start, and give me some next steps. Because if I can get this ground glass supercharged in the positive direction, if we can then just add a binder to hold all the glass, the ground glass in this positive, super positive state, then similar to a permanent magnet, which has a permanent magnetic wave, this will be a permanent electric, which has a permanent electric charge field. Pretty cool. I think I said wave, I'm sorry. A magnetic field for a permanent magnet. Here, this is an electric field for an electret, or permanent electret, if you want to follow that. And so at the bottom here, I thought, okay, this is fun with colors. Maybe it doesn't make sense. So down here, I show how this is one particle of glass here at the bottom in yellow. And as it's getting charged, it's pushing away the positive. So you know how like polarities, they repel each other. And so it's going to push to the left here, these little pluses in orange, but the electrons are going to be attracted to it. So again, the electrons get all excited. They're coming to the positive. Oh, they go right to ground, because ground should be positive in relation to these electrons. And so they'll come down through the diode, they can't come back out. So then glass becomes super positively charged. So I 3D printed, I ran out of baby blue, so I had to throw in red. So that's why it's multicolored. And so here you can see that I printed the rotary here. And this is the lid. And then here's the stand that's going to hold the motor and allow the drum to spin. Also, too, this is a great book on electrostatics. I recommend it, highly recommend it. It's for the regular person, and he actually teaches you how to build electrostatic devices. Unfortunately, no electrets. I can see why electrets are so interesting, because people haven't done a whole lot with them. I really think Jarvis is going to be the person that reinvents electrostatics with his electrets. I can't wait. So here we go. So if you notice that it looks like a bunch of trees, this is the extra support filament. It's a setting on my printer, and I found that you waste a lot less filament, and it looks really cool. It looks artistic. It's easy to take off too. I don't know if you ever tried to clean support filament, but it's a task. But these tree type structures, it's pretty easy. All right, so I need my motor. I literally have bins of motors from the thrift store, and so I need to find the right motor for this. I usually keep like motors together, but of course it's a mess. This one looks like it's going to work. And then I need diodes. I need a high voltage diode, and so I found some high voltage diodes from taking apart microwaves. Now this may be the wrong kind of diode, and Jarvis will have to correct me on this one. We may need what is called a TVS, which is a transient voltage suppressor. I think it's called a TVS diode. So we may need that, but I'm going to try this one. And I'm going to go into my wire bin, find the right piece of wire. This is what I need. Here are the pieces, the items. Now I'm just showing you this as more for demonstration purposes. Here's my ground glass here, but it's actually some ornamental plastic pieces. But I kind of want to show you what the drum looks like, how I'm going to be spinning the drum, what's going to go inside the drum. And so I wanted to give you a visual for this because I'm actually going to physically be working with this tumbler, is what we can call it. I know that Jarvis speaks about the bake and shake method. I think this is going to be more the bake and rotate method, or rotary and bake method. So here I'm now sort of constructing it again to give you a sense. Put aluminum on the inside. I'm going to connect it to aluminum on the outside. That way I can get this electricity driven out and through the diode and into ground. Here's how it's going to work. And we're going to just make sure that we're set up. All right, looks good. We're going to be able to pull those electrons away. And we're going to connect things up. I really like these flip snap connectors. They allow you to connect anything real quick. And so these little blue items here, you got to be careful though. When they snap back, they'll pinch you. But for rapid connections, these little guys are indispensable. I'm always looking for a better mousetrap, and these seem like the flavor of the day. I'm always looking for something that allows quick connections. So these are great. So I'm going to hook the diode up. Let's get this thing wired up. Is it going to work? No, this is only for demonstration. I haven't really had a lot of time to do more than this. And so I picked up these 2-inch diameter solid copper spheres, and I'm going to be using them to kind of simulate earth ground. I just wanted to have a whole bunch of free electrons for my experiments. And what's interesting is if you look up these solid copper spheres, they're super expensive. And so I thought, I'm not going to pay $150, $200 for a copper ping pong ball size copper. But there's this, I forget how to say it, Tai Chi. They sell these for like a homeopathic therapy. And I found these, they're roughly about $40 a piece. So good deal. All right, so now I've tumbled the glass and I've done all the work, and out comes what? An Electret. Perfect condition. Look at that. Oh my goodness, we're ready. No, I'm kidding. I'm just trying to do this for demonstration purposes. This is what I was telling you. They're called large boating balls. Oh boy. See, it's going to open up for the junior high bathroom humor. But they come in these little pouches. These little copper spheres weigh 2.7 pounds each. It's when you grab them, you're going, what is this? They're so heavy, even though they're so small. All right, so just clearing out the miscellaneous. The presentation is going to be short today, guys. Nathan has a cool format that he's going to be rolling out tonight. And so here, I'm using my new coil winder. I'm finally getting the cone-shaped coil wound. Kind of wanted to give you a little bit of how it's wound. Once I change to the next groove and get it set in, now it's time to twist it. And here we go. This has been great. This takes days down to hours in coiling. So I appreciate that. I wanted to share that with you. This is a version 2 of the manual coilers that I've been selling on Amazon, and a reasonable price, $50. And it has this drill bit chuck here, so you can put whatever type of post you want to put in them. And it's a great deal. So Eric Dollard is part of a group that I can't remember their name. Ian could tell you. And they had this young man. He was 18 years old, and he was dressed in 1940s clothing. And he did a presentation where you can see through things but without using X-rays. And so he has a website, and here's the tube that I'll start experimenting with when it comes in. But I can't wait to see how to set up my Tesla coils to power this and allow me to see through walls or all of the capabilities of this device. So I can't wait to play with it. Thought I'd share with you guys what's next. And last but not least, when I look for the resonant frequency of my coils, this is the setup. It's the oscilloscope, one wire coming down. It's the signal generator, one wire coming down. You connect it to a resistor here, and then here you connect it to one end of your coil, my sphere being the coil. And if you look at the top of the screen here, you see the sine wave of the oscilloscope. What you do is you just turn the knob on the frequency generator until this shrinks, until it goes down as far as it'll go down. At the point where it has the least amplitude is the resonant frequency. So this is about as easy as I can explain it. Let me know in the chats if you want. In the next presentation, I'll walk through these steps, but this allows you to find the resonant frequency of pretty much any coil. And I thought, what's an easy way to explain it? I thought this would work. And so this is my last slide. When I'm watching Nathan's lectures, presentations, I'm always zooming in and looking at the equipment he uses, so then I can extrapolate with some math how efficient or where his systems are at. And so this is one of those drill ins. And so just to let Nathan know, he has a lot of fans like me, and he does great work. And that's it. All right. That is the end.
What's going on, Sean? Can you hear me?
Yes, I can hear you loud and clear.
Very good. Okay. Yeah, I'm in the lab right now, or my garage, however you want to say it, getting ready to do some experiments for you guys. But that's cool, man. I do appreciate it. That was a really cool presentation.
Thanks. I appreciate that, Nathan.
So, all right. I'm gonna let you I'm gonna let you check out the chat and everything. Hopefully everybody can see me over here. And I'm gonna put this thing real quick on.
So Nathan, can you hear me okay?
Yeah, I can hear you.
All right, awesome. So hey guys in the chat, I will go back and we'll answer your questions about my presentation. But if for now, if that's cool, guys, Nathan's gonna do a live presentation, a live experiment of some of the things that he's been working on in his past videos. And he'd like to open it up to where as he's experimenting and explaining, feel free to comment a question, and then I will interrupt Nathan with the question, and he can comment or answer real time. And also too, if you have comments or questions, they're also for you, Ben. So not just Nathan, but for you guys. Ready when you are, Nathan.
Yeah, all right, let's just fire this thing up. So I'm just running my ZVS Tesla coil here. The wire right here, the green wire is connected to the rod that goes down the center, but on the bottom side of it. So you're getting the one wire energy, and we're just going to clip it here. This is one of the tests that I did, and I just wanted to show you, this is just, you know, PVC pipe and tin foil. There's nothing really to it.
Mind-blowing.
So we're going to take this light here, and I'm just going to turn it on. And there we go.
And Nathan, just real quick, because I know you can't hear it, there's a high-pitched squeal.
As soon as I put the light next to it?
Yeah, as soon as you put the light next to it, just to let you know, because Nathan can't hear that squeal.
No, I can't. I'm deaf. So that's so cool. But yeah, you could pretty much put anything in there. So we'll just shut it off, take that out. And then a lot of people bring up a Leyden jar. So we, you know, not quite a Leyden jar, but close. It's just got some foil on the outside, some water on the inside. There's actually salt in this one because people like the salt water. So just turn this thing on, and there it goes.
Wow. You got a question in the comments, Nathan.
Go ahead.
So do you prefer a ZVS or a modified Slayer exciter circuit in these experiments?
I prefer the ZVS right now for what I'm doing and testing everything. I'd have to say my Slayer exciter, though, if I wanted to run it at 40 volts, man, I could do it all day with this too. But this Tesla coil was set up with the ZVS, so I used it. I truly like my Slayer exciter, though, for other things. Like if I go outside or something like that, because it self-corrects on the oscillation because it's forced oscillation. So I really do like that one a lot better for going outside than I do the ZVS because it's a little more finicky.
Awesome, Nathan. John Curley asks, how far is the field with nothing inside the primary?
Let's just find out. It's basically an energy transfer, like a little well. So,
wow, that's crazy. And you're getting a sort of sci-fi, 1950s sci-fi sound when you move it.
I can put my hand down it.
Wow.
Wear it like a bracelet. It doesn't really matter.
So Nathan, when you put your hand in it, the resonant ring sounded different.
Oh, it did?
Yeah.
Well, let's see what it is. Hold on. Let me see. Let me check the oscilloscope right quick while I'm doing it. It moves it just a hair on the oscilloscope, but not very much. This thing's so in tune right now. But yeah, there's a field in it. So basically there's energy in this at all times. So no matter what you put in there, it's going to light up. So I know you're probably thinking, well, it's probably not the water in here, right? So let's just find out. So if it's just the field around this, then it won't light up any brighter when I put it in the water. But if the water is actually taking the energy in, it should light up brighter. Okay. It's fully submerged in the water now. You see how bright it is. It completely changes. Sorry, camera's getting out of tune. That bright light gets to it. It's kind of blurry. Hopefully it'll fix in a minute. Sean, you still there? Can you still hear me?
Yes, yes. So in the comments, they're talking about you have invented or designed or built, sorry, a theremin. Have you heard of a theremin instrument?
No, go ahead. Oh, is that one that you move your hand over like Sheldon did on The Big Bang Theory?
Yes, exactly. It sounds just like that right now.
Yeah, hopefully that camera fixes, man. That's kind of annoying.
Yeah, the autofocus, it should if you move around a tiny bit. Maybe like wave your hands in front of it. It should readjust, and it's designed to pick up motion. So
yeah, well, let's hope it fixes, man, because it makes some bad experiments if not. So let's have a little fun here. We have it off, so just going to clip it. I'm going to clip this on. This is the top of my Tesla coil when I normally want to run it. Just a little donut, nothing special. Come on, camera. Work with me here.
you might have to wave something a little closer to the camera. I don't know, because it went out of focus when you had the fluorescent tube close. Oh, there, maybe. No.
I don't know that I could get any closer without detaching everything.
Yeah. Just hopefully it'll adjust.
All right.
Get the gist.
Let's just turn it on. We'll light it up right next to it first.
Oh.
So You've got the light going.
Mm-hmm.
Definitely puts off all the energy you want.
Wow, that's crazy how it changes the frequency. You could hear it.
Yeah. It's visual and audio. It's so cool.
Does it do like a little turntable when I do that?
It does it has like a whirly whistle. it's funny.
That's so cool. It lights up even brighter. It lights it when you touch it. So you can see that it looks like a...
Wow.
The sound is incredible.
Yeah, as soon as you touched it, it got real loud.
Yeah.
like SOS.
Yeah, that's crazy.
So
That's so
Nathan,
cool.
a question, Nathan.
Go ahead.
Can over unity be used from this somehow? This is coming from network Metatron.
The configuration of the coil probably prohibits it. I've been working with Ian on this and looking at different things. It's just the way that the Tesla coil is designed. There's only one magnetic field that operates inside of it. I'd have to multiply it in order to get it. So I don't know that I can necessarily get it with this. And don't get me wrong, you can put a lot more power into it, but if it's not multiplying right, it probably won't do it. So I've been real discouraged about that, trying that lately.
Nathan, you mentioned that if you did not have a center with just the windings of the coil too, that you could create some sort of focused energy in the middle.
Well, you're looking for the magnetics to go inward, right? But the coil is set up like this, where it goes on the outside, right? What if I change the geometry and put it on the inside? This part. Would that change it? Would it push the pinch in further and get a better feel? So I don't know.
I mean, it sounds like it makes sense.
Let me see if I can't fix this, because this is going to get annoying real quick for me. I'm going to see if I can force it to autofocus. No. All right. Oh, I can't get close to it. Let me see. Always technical difficulties, huh? All right. Give me 1 second real quick here, okay? Go ahead and figure out the next question, Sean. Give me a second.
Sure. I'm going to jump up to some of the questions during the presentation. Let's see. All right. Lots of love in the chat. Thanks, guys. Great to see you. Let's see here. Okay, there's some junior high bathroom humor. It's basically not a live stream without that, right? Right, Ben?
Of course. It's probably coming from me, right?
Right, exactly. Exactly. So it looks like we have a question. Is there a speaker magnet below my setup? No, I wasn't using any magnets.
Sean, should we pull Nathan back up on stage, or is he off stage for a reason right now?
He's off stage to fix things, so he thought
okay.
I could just jump into the questions a little bit.
Oh, okay. Okay. So I see. He's got a wireless mouse to control. Nice. Okay. Just making sure.
Now we're good again, right?
Nice.
Yes. Awesome.
Okay,
And
sorry about that.
The coil.
Yes, I got my Joker coil. I put it outside, but unfortunately, it's not dark enough to get the true effect of it. So it's just going to look like normal, but you might get some cool sounds out of it. So let's go ahead and check it out. We'll turn it on here. Is that making sound there?
Yeah, It's total the theremin. I think that's how you pronounce it. It literally sounds like a musical instrument. Not anymore.
Now that. Ooh, I just heard my computer go off. Oh,
You have so much energy in that room. It's just it's affecting all your equipment.
yeah. So how about now?
No sound.
No sound, huh? Let's try.
No sound.
That's interesting.
You got a comment here saying that the salt water messed up the camera, possibly.
Maybe. Well, we could try it out. I mean, there's always different ways to do stuff like this. I got this little coil here.
Nice.
And I'm just simply going to put it in the center, and I'm going to make this coil right here. I'm going to make it the Tesla coil part, the winding. So if I could just hook that to there. I want to make sure the wire is off of it. So let me just grab something random over here and put it under here. I just, like I said, I want to make sure the wire sits off of it. Okay, all right.
Wow. Incredible.
It's an energy transfer more than it is resonance in doing it right here when I'm doing this.
And you're messing with the focus. It's going in and out of blurry, and it's still okay, but it's changing.
I got to work on that. Get me a camera that's further away, huh?
Yeah, or put a Faraday cage around it or something.
Huh. Yeah, but it worked. I mean, look, this stuff in here, man, you grab it, it's fine.
There's a question in the chat, Nathan. Stephanie Greener's warning comes into play during high cavitation and high voltage.
Okay. What was that warning?
I don't see it in the chat, but do you want to speak to high voltage, high cavitation? I know you shared a little bit with me before we started the video.
Yeah, so I was doing tests on this coil right here. And let me see if I could show this. Let me just attach that one. Okay, so, all right, we should be good. Just gonna pull the sleeve back, because the energy will go through it. You see that?
The sound is back.
It changes things. So you'll get a positive effect. If you get it the right distance, you get it too close, it'll drop your resonance.
Your oscilloscope's not changing.
It's not changing?
No.
Maybe I don't have the power up high enough. Hold on. Let's see if it changes now. Anything?
Yeah, you can. Oh, yeah. Oh, yeah.
It went right out of resonance, didn't it?
It squealed like a pig.
So I was just curious, if I take a bigger pipe and I get, like, this is 4 inches for the one right here. What if I put like an 8-inch pipe in there? Will it be able to put energy, rods around it and pick up the energy? Or can I put one of these coils, like this one, the copper, on the inside? What would I get? And the whole thing is the more heat you have in there, the more amps you get out of your coil. So it forces the field to get bigger. So that's the whole reason of doing it. It's really interesting, actually.
It's the tinfoil secondary coil still gets me. I have no idea. And I've built a few Tesla coils I know a little bit about them, and that
Yeah, that is almost like magic, right?
it looks like a trick, is what it does.
Yeah, it's
Well,
so cool.
yeah, it just works. I mean, look, you don't have to have anything hidden around it. You just take this coil right here, another one of my number
And
one coils. Go
And
ahead, Ben.
forgive me for my ignorance, because I'm not too fond on how the inner workings of a Tesla coil. But from my understanding, you can't just hook up a standard Tesla coil and get these results. You have to have this specific configuration with what
No,
you're doing.
what I'm doing is, and I guess it seems like a trick, but what I'm trying to tell you is this one wire energy is a different energy. So it's not resonating the foil. It's not like a coil where you have the windings around and creates a resonance. Your energy transfer here. So you basically have an energy field that comes out of this one wire. Then it
Right.
goes into and transfers to this.
So I guess my main question is kind of obvious, though, the answer. You can't do this without putting that tube down the throat of the Tesla coil, right? Is there any other way to do this without like putting that rod down the center of your primary Tesla coil?
You can hook it up to the hot side of the Tesla coil, so the number 2. And it'll change the capacitance in your coil. So what you'll have is, as soon as you put this down the center, you fry your ZVS board.
Okay.
So because you're so far out of resonance at that point that it's pushing back on that coil so hard that it's just going to immediately heat up everything and your MOSFETs will blow. Now,
Right.
it won't matter if you have a Slayer exciter or a ZVS, it's going to fry it. So the thing is it breaks it with an air gap. It's not a, how do I say this? It's an open circuit. It's not a closed circuit. So in a closed circuit, anything you have attached to it affects it. This only affects it based on the amount of energy that you're pulling or pushing it back into it. So as soon as you push energy back this way, then it affects it. Other than that, it's not going to affect it. Once you've already adjusted for the rod being down the center, you're good.
So it's like kind of putting a tap on it without affecting the original. That's cool. Okay.
That's why you do it. It's breaking the energy. So, like I said, if you connect it straight to your number 2 coil, you're going to start frying stuff. And then everybody's going to go, oh my God, you did it wrong or this and that, right? Well, no, you just didn't listen when I told you the rod down the center was a broken open circuit. And then it's just getting extra electromagnetic force from it. So the energy, it's built to go radiant out, right? And that's why the winding on the inside would make such a big difference, because the energy is focused now on the inside versus pushing out. So all that energy you get out would now be pushing towards the center. You see, that if you want to get an over unity effect, that's what you're going to have to do. You're going to have to force all that energy to the center and not anywhere else. But my Tesla coil, when it's on, doesn't even break out with energy. My number 2 is right here. There's no breakout on it.
So in your professional opinion, working with these coils and stuff, would you say that this is kind of like the direction that Tesla intended the Tesla coil to go in terms of what he actually intended it to be used for practical applications?
So there's 2 ways to think about this. Tesla did a circuit with one wire, and he has patents on it, and Ian will tell you about them. And it's about the hot side energy. So there's a debate a little bit, I guess, is the rod down the center the same thing? A lot of people say no. And they always talk about the hot side energy. Well, the hot side, right? Here's the thing. I'm breaking the hot side with the rod down the center with air in between. So
Right.
if I took and I simply hooked this right here, and I said, all right, I'm going to take this hot side, but now I'm going to let the radiant energy here go to here. Or I build a fork around it. Or I make this a double fork, right? Like, you know, like this. So To me, there's no difference. To other people, there is. I'm still breaking the hot side with air.
Okay.
So to me, there's no difference to other people. They say the patent is the patent. You follow the patent. There's a spark gap on it. You got to follow that too. By the way, there's 2 other paddles on there. They use this for other purposes, and you got to have those too. To me, as soon as you broke it with air, you have the cold side of energy. So that was kind of the whole thing. I didn't reinvent the wheel. I just used it the way he was doing it in other experiments.
Right. And do you attribute some of your breakthroughs from some of his patents, or did you just use the experimental intuition to kind of come to this?
So I had this right here from when I did my grabby flyer. And I was trying to explain to everybody by putting the rod down the center, the energy changes. And nobody understood, because I put the wire down the center and they go, oh, it's the same as when you hook it to the number 2 coil. Right. And I didn't come up with this, guys. This was done from the Alexi, who built the grabby flyer, showed it. And it's very simple. I mean, this is not my thing. This is just something I built out to see how it works, and I wanted to prove that it pulls more energy and how you can focus energy from a break from the hot side of the coil. And I was able to do it because the cool thing about this is if you can get a stable enough circuit, and I have a high frequency here, and I push it back into here, if it's on my Slayer exciter, because my Slayer exciter is forced resonance, okay, which basically means the number 2 is not excited as much as it is the wire going to it and forcing it to resonate. What it'll do is it'll take this far on my coil, and it'll change the frequency of that top half of the coil, even though I didn't change that coil at all. But that's what the tests show. So I can impart frequency back on my Tesla coil as a feedback, and that's what one of the shows or one of the tests were showing.
That's awesome. I'm really excited when, you know, I hear somebody's like research kind of leads them on a different path and revelations in a different area, you know, because that's really cool how you know, you're working on one thing and then you kind of like stumble upon you know, something that you can apply to a different area, you know.
Yeah.
Awesome.
That's really
cool,
awesome.
Man.
There's another question, Nathan, and thank you for that, Ben. What if you use 2 separate aluminum foils to create a capacitor? Wrap one foil at the top of the tube and one at the bottom. Leave a space so they don't touch or arc. Then rectify to charge a battery?
Maybe. It'll put energy in the water. I wanted to do a saltwater cell with it and see what it did, see if it worked. But it's entirely possible. And what was the reason for the separation? Did you wind them the opposite way or something with multiple layers, or was there more to that?
I think they were just making the point of taking that high voltage, turning it down to a low voltage, high current, and then use it like charging a battery. So I think was the point of the comment.
Well, okay, so let's talk about this a little bit, because there's a difference in the energy. This energy transfers, so it would transfer no matter how much you cut it right here in the center. Okay, it would not matter. So the thing is, though, it's a transfer energy, but it's not voltage like you would consider from the number 2 coil. See, that same experiment hooked to the number 2 coil would give him what he wanted easily. You know what I mean? You could charge things with it. It'll run like regular energy. This is acting differently. And I don't know the best way to say it, but it imparts the energy on there, but just in high RF. And the magnetics are forced away from it a little bit. So it's not the same thing.
That makes sense. Lots of enthusiasm for Gerald.
He said he was coming tonight, man. I honestly don't know what's going on. I hope he's okay, and I hope everything's good. Hopefully
Yeah.
it just pops in.
Yeah, I agree.
So, I mean, you guys missed the guy. I missed the guy more than you guys do. I mean, so
But
anyway. All right. So everybody likes pancake coil, right? I got a 12-inch pancake coil.
so cool.
And we'll just connect one side. Well, see, that's kind of the thing too, right? It's one wire, so you're only connecting one wire. That's it, not two. You don't have a whole circuit connected to this. I mean, think about it. My rod is down the center. It's not touching any part of my number one or number two coil. It is completely independent. So I have absolutely zero circuitry connected to this. I mean, think about that. My number one coil is not connected. My number two coil is not connected. Gerald's in the chat. Right on. But it's completely independent of everything. So, hang on, guys. I'm just going to put this up real quick. He's having camera troubles. All right. Gerald, just leave the camera off and use your mic, buddy. So, anyway, let's go ahead and light this thing up, man. Tell me if you guys get any sound out of this one.
Nathan, can you walk us through basic construction of the Pancake? What gauge wire? Is it a bifilar?
Okay, so let's turn it off real quick. This is Master Evo's pancake coil. It is basically just speaker wire. And it's been so long since I wound this thing. You start in the center, you wind it out, glue it the whole time, then it connects back from the center back to these outside wires. What you're going to do is there's a red wire and there's a silver wire, and in this part right here, they attach together. So one and one, and then you bring the silver wire out, the red wire is out here, and it gives you two leads. So hopefully that made sense. But
yeah, that makes sense.
Yeah, it's a bifilar coil on Master Evo's design. So if you watch him how to build it, and I would suggest that's the video you watch to do it, that's exactly the same way it's hooked up.
Have you wrapped the fluorescent tubes in aluminum foil?
No, I have not. What would be the reason? I mean, the transfer in energy. Is he looking for Don Smith's device? Is that what he's looking for? Or Joe Legacy, maybe, in what he's doing?
To get it to act like a capacitor, like you're charging up a capacitor.
So, okay. Check this out. Because this is energy on at all times, right? If I took foil and I just made a high voltage capacitor out of it, I could put it right in the center and it would act just like a high voltage capacitor and multiply that energy out.
Wow.
So if that's what you're looking for is a high voltage capacitor and you want to do it out of aluminum and you basically want to take a slip sheet of clear and put it in between them and then create a high voltage capacitor by rolling it like a cigar and throwing it in there,
yeah,
it'll activate that sucker wirelessly. And it will produce power around it.
Wow.
So there's no issue there. Yeah, that'll work.
And so that capacitor is charged wirelessly?
Yeah, because remember, it's like an energy well. So anything you throw in the hole, it lights up.
Amazing.
It's basically transferring energy. So you could say it's either transferring the electrons from here to whatever's in there, or it's forcing the electrons to pull into whatever item is in there from the room itself. So, or it's just activating the electrons on the aluminum. I don't know which way. I'm not a physicist. I don't do all that. I see mostly things as fields because that's what I can see when I'm experimenting. But you'd have to translate it yourself into which way it's working.
Amazing. Real quick, what input power are you putting into this experiment? How many volts DC? How many amps are you working with?
So basically for every 10 volts, I get 2 amps, and that's on a general scale. So when I get it up to 40 volts, I only have 8 amps in it. I generally run this thing between 10 and 20 volts. Once in a while, I'll get to 22 volts, but not very often. Again, this is low power. So when I ran all of the light bulbs outside, it's the first time I ever hit 40 volts.
Amazing.
Gerald, what's up, buddy?
Hello. Can you hear me, Mango?
We can hear you, man.
Right on. You can't see me though. Watch. I'll turn my camera on. Check this out. Woohoo!
Got nothing.
Hey,
Not at
Gerald.
all. So if I shut it off, at least you'll get my lion's head. Hey Ben,
There you
how are
go.
you? Sean, amazing as usual. I can't say enough, man. You're gonna do something later that's gonna blow your own mind.
Thank you so much. I appreciate that, Gerald.
There's a lot to explain. I've been kind of working in the background, and I've got some news a while ago, so I've had to work even harder doing more cooking to pay more bills. So that's irrelevant. You guys have been doing amazing. Nathan, you're going crazy with all these experiments. I love it. It's great. But there's some clarification I got to give you off screen so that you're doing awesome. There's some stuff you shouldn't experiment with.
Oh, I
We'll
know.
get into that later.
I
And then we'll
connected this
clarify.
thing.
We'll do
I
a
connected
video
this
on
thing to an iron plate, and I probably shouldn't have.
Yeah, and there's a little bit to do with the aluminum too.
Oh,
You're getting energy from the aluminum, but how do I put this? You could be using the aluminum in a different way and increasing your energy output. And I'll
nice.
leave it at that for now.
Oh,
because-
always a hint.
Here's the thing. There's a lot to what you're doing that I haven't explained. And once you understand it, it opens up another series of experiments. But those experiments are dangerous. So
Oh,
I've been
come on
kind of what's the word I'm looking for?
Holding back.
To sort of release certain information. You know what I mean?
Yeah, oh, I do.
And it's not a dig to you at all, dude. You're awesome. You're amazing the way you're taking care of business. Like you're just killing it. I love it.
And you bring up, you bring up a good point, Gerald. Maybe Nathan can walk the chat through some of the pitfalls and how safety works for him.
Yeah, absolutely. See, the energy that Nathan is using is not normal energy. But at the same time, aluminum with, I won't say fully ether. I'll say, because it works with high voltage as well. Aluminum at certain voltages flips the energy. So it'll flip the phase. So you'll go from positive to negative. So
That I did know.
yeah, so you have to be careful how you're using it and where you're using it. And that was kind of the conversation I wanted to get into with you. Because I don't want you to hurt yourself, brother. You know what I mean?
Do you know how long I've been telling people it does that? Like, it literally will change from positive to negative on certain sides or the whole thing. And just, I do that on my gravity flyer disc in the center.
Yeah, well, you're using an aluminum plate, right?
Yeah.
Yeah. See, there's a reason for that. He understood that you're going to flip that pole when using that aluminum plate. And when it's spinning, you're creating current, right? So that current flow flipping in and out, in and out, in and out, in and out creates what? A vortex, but a compressed vortex because you also have your magnets. You know what I mean? There's a lot to what's going on, but it's simple to explain once we kind of get there, sir.
Okay, so hold on. The Kashmir effect, right?
Yeah.
You have two plates, you put them close together with as much voltage as you can, as long as it doesn't spark over. Okay?
Yeah.
So check this out. I think people who say it need to understand this. If you do not spray that plate on both sides with some kind of clear coat, put something over top of it, you'll get high voltage spark over. And if it's aluminum, you're going to create a laser.
Yeah.
Yeah, so it's completely dangerous if you don't know what you're doing. And if you just throw it out there like it's casual, if you understand that you need a coating over the aluminum where both sides are coming together, then you're safe. You know what I mean? Then you're getting your pressure that you're looking for in your capacitance right there.
Absolutely. You're absolutely right on that. And capacitance is a big deal. There's a lot of devices or a lot of materials that have capacitance. Like take the bulbs that you're using. Now, there's not much capacitance in a fluorescent bulb, but glass itself holds a particular type of capacitance that increases your output. So
Yes,
that
it does.
helps fluoresce, right? There, I love this tech. I've been studying it for so long, man. I'm telling you, it's great. Where you're at's just mind blowing. It's great. Can't say enough. But yeah, it's like Vortex says, just be careful. If you don't understand exactly what the materials you're working with can do at low voltage, high frequency, high voltage, high frequency, don't play with them because you can hurt yourself. Look at what Bob Grenier was saying about, I can't remember. I think it was Susskind that had died of cancer. And it was like within 30 days, man, boom, gone. Because it was such an aggressive energy that hit him. And they believed that it was an EVO that got into his body and created damage. Could have been. We don't know. But I'm just saying be careful because he was playing with aluminum as well. Right? So it's how you use it in the system. So as a safety for everyone listening, if you don't understand the materials you're playing with, go back, do more research before you start.
Yeah. So one thing I'll tell you guys, and I did a video on it and I won't release it. And it's because it's destructive energy. And I'll just let you know, I put my number 2 coil to all these experiments and the energy coming out was not constructive. It was absolutely destructive. And it was the worst feeling I've ever had working with energy in my life. It was not something I'd ever want anybody to repeat. I don't want to show them how to do it. And I wanted to vomit for 3 days. It was just awful. Dude, it just puts you in a bad mood. It did everything you can think of that could go wrong. That was it.
Absolutely. And I could get into what that means, but I'll tell you, if I do, it goes into the woo and it's going to throw some people off because you're talking energy now. In the last comment section, when you guys were doing a live, I had mentioned something about the Vamana. You guys know, you know what a Vamana is? In ancient texts, it was in the Vedic text, it was a ship that floated and it had anti-gravity and it was controlled by a pilot that would control it with his mind. But that pilot had to go through a sequence of training events in order to make him pure to steer the ship. And why is that? Because he was steering with his spirit. Okay, so through meditation, through training, through the understanding of how energy flows, he was able to steer the ship. He was able to make it raise, lower, the whole 9 yards. But at the same time, if somebody fired at that ship, the pilot felt it because the plasma that was interacting with the ability to have anti-gravity was the same plasma interacting with the man's spirit. And because the two were connected, as they were flying, they were one.
You know what they say? Whoever felt it, dealt it.
That's pretty good.
Thank you, Jarvis.
Hey, Nathan.
Yeah.
Did you want to talk about the flyback energy versus the other energy regarding how you feel?
Oh, yeah. I don't want to get into it because we kind of dive down a rabbit hole of stuff we're not allowed to talk about.
Okay, no worries.
I wonder, Nathan, because I could talk about it on my channel, if I was to do a live and you were to come on my podcast, would it still affect your channel?
No. Not as long as it's on your channel, not on mine. We're fine.
Interesting. Maybe
Yeah,
it's
I mean,
try.
there's stuff that I got in trouble for on YouTube, guys, and I just stay away from it. And
Yeah,
it's
apologies.
just a lot easier. I don't want any more trouble.
Well, see,
Yeah,
here's the
agreed.
funny part, though, right? Well, it's not funny. It just sucks. Shout out to Bob Grenier if you're listening. But people like Bob Grenier and Malcolm Bendall and Alchemical Sciences, big shout out to all you guys. You guys are great. You're doing awesome work. But they managed to get away with talking about the very subject that we can't. And they don't get strikes. They don't get warnings. They don't get shit. That makes me wonder why.
Yeah, well,
I'm
I don't
just
know,
saying,
man.
right? I'm just saying. I'm bringing it up because the subject that we're always sidestepping is so freaking important. It's insane. It goes to electroculture. It goes to a lot of things.
You know what, though? I'll be honest with you. If that's one part of the secret that they don't know, then we'll just let them kind of float around in the dark.
Well, it's been brought up. In fact, Bob Grenier just did something talking about it.
Yeah. Well,
so it's interesting. It's just how some are suppressed and others aren't makes me wonder why or how. I mean, I know the answer to that question, but I'm not going to. I'll let the audience come to their own conclusions.
Well, whatever. You know what I mean? It is what it is. I'm just going to deal with it.
Is. But needless to say, this energy that you're playing with, the cold side, yeah. Think about it like this. Hot energy, cold energy, being the negative, is going to attract positive, right?
Mm-hmm.
So if you had a buildup of positive energy somewhere in the close vicinity, we'll say, and you had the ability to envelop that with negative energy, you would be able to null and void that positive energy that's built up in the local vicinity. Do you understand what I mean by that?
Oh, dude, I'm one of the very few people who probably understood that.
All right, so I'll say no more.
Like I told you, I worked with this stuff for a long time, found out a lot of secrets that basically people just don't want to hear.
Have you found out where the monopole is in your system yet?
No, I haven't even looked, Gerald.
I'm not going to tell you. Here's the thing. When you start understanding where the monopole is, you're going to start playing with things. Things that...
I think, honestly, Gerald, I'm going to have...
What's that?
Sorry. I'm going to have to change the coil configuration to get to it. And when I start changing the size of the coil, I'm going to start playing with the heat more. And then it'll become very apparent where it is.
Sorry, I got a little bit interrupted there, but yeah, I caught that.
Thank you, Vortex.
Yeah, thank you, Jarvis. So, yeah, I don't know how to say it. It's the wrong configuration for what we want to do.
No.
Because...
sorry.
Yeah, it's the wrong configuration for what I need to do. I need a bigger coil.
Okay. Can I elaborate?
Go ahead.
Okay. It's not the wrong configuration. You have it and you don't have it. Okay. So it's not special winding. What it is where you put your system, how you separate the system, and what you do with the system in between. It goes to the hairpin circuit. Now, I don't mean any disrespect, Nathan. You're a freaking genius, okay? The hairpin circuit does a little bit more than you explained.
Probably does.
Yeah, and I'm just saying that because I respect you, man. You're like, no issues at all. I ain't dissing on anything you said about it. But there's a little bit more to it than that. And Tesla found it by trying to understand where the cold energy was, how he moved it, and where it was moving to. And that goes to the understanding of a monopole.
Okay.
Thank you, Chris. Very generous.
Yeah, thank you, Chris. And thank you again, Jarvis. I appreciate it.
What Sean has done and his geometrical forms and the type of voltage that he's pulling, he's like, how do I explain that? Oh, you know what? I got to leave that one out for now. I'm sorry, because the minute I start to explain that, it's going to go into something that's going to take us into the next level. And there's something else you have to understand before we go there. And if you don't understand it, you're going to hurt yourself and maybe the people around you. And that's not what we want here. And we want to do this safely.
You're gonna leave me with that cliffhanger. Thanks, Gerald.
You know what? I'll tell you this, Sean.
Okay.
What you've done is amazing. You've overstepped about 6 different steps that people have to take to get to where we're going. You're like one step away, and I think it has to do with an understanding that you don't have yet. Not your work.
Hold on, Gerald. Hold on. I know the answer to this.
Oh, do you?
Thank you.
Oh, yeah.
Don't get me wrong, Sean. I believe you're a genius in your own right. I'm not dissing on you. Okay?
No, not
Please,
at all.
when I try and teach you guys what I know, it's not to be insulting or anything like that. That's not the way I believe.
Oh, no, I don't take it that way.
Hey, Gerald has taught me. Yeah, if it wasn't for Gerald, I probably wouldn't be where I am with my research. I showed him the H wave, and he immediately was like, "Yeah, you're not quite there," and I didn't understand, and now I do.
And you're doing amazing work, Ben. You really are.
I remember the conversation, Gerald. I'll leave it at that. We'll talk about it later.
Thanks
again,
Gerald.
You might just have it. Yeah.
I'm very bad at short-term memory, but long-term memory I'm fairly good. So
okay, so I'll give you a big hint, Sean. Your lake. Oh boy, your lake. It could be a very, very important thing in your future. It has to do with your work. And I'll leave it at that.
Oh man.
Right, did it again, didn't he? He's good at that.
I love them. Cliffhangers are great. You want to know why? They make you think. And if you think, you research. If you research, you learn. And when you learn, you don't just get told. You know. Right? Give a man a fish, he eats for a day. Teach a man to fish, he'll eat for a lifetime.
Oh, man. All right. Well, thank you, Gerald, I think.
Real quick, I want to show you a few more experiments, guys. Gerald, you hear that sound and stuff?
Yeah, I absolutely do. Do you know what that sound is?
All right, go ahead and tell us why I turn it on.
From my understanding, it's the flow of electrons creating sound because of the way that it's flowing between your primary Tesla coil and what you're holding above your secondary Tesla coil. Regardless of whether it's an aluminum tube or a rodent coil or whatever, it's acting as the second part to your first Tesla coil.
Yep.
That makes sense?
Yeah, awesome answer. Yes.
Yeah, it's I want to say it. Yes. I don't know.
If my camera was working, I'd be able to show you what I have on my whiteboard right now that explains everything that you're doing and ties back to the hairpin circuit and the only thing that you were kind of missing in it.
Okay.
But I'll get my camera working. I know what's wrong. I have to get some drivers downloaded that I'm missing.
Gotcha.
Yeah.
Well, just having you here is awesome, Gerald.
Yeah, sorry,
Yeah.
I've been out, guys. Like when I have camera problems, I hate it, so I just stay out.
We
And
miss
I've been
you.
busy.
Yeah.
Well, my wife's kind of got laid off from her job. Get this, dude. Her job, she worked for the United States in Canada at home. It was
Wow.
a company that was from that, and all of a sudden they're downsizing, so she gets laid off. So I've had to put in extra work and put my pedal to the metal to get stuff done, right?
Yeah.
That's why I haven't been
Understand
around. It's just life.
Yeah.
Yeah, sorry about that.
All right.
No, don't apologize. Hey, man, everything that goes wrong is a chance for things to go right.
Yeah, good point. You're right.
What were you going to say, Nathan, before I cut you off there?
Oh, no, I was just going to show you an experiment. Okay. So this is a water experiment. Did you hear the sound last time I did this?
No, I'm not sure if I did.
So tell me when it changes sound, because I can't hear it.
Yeah.
Yeah, there it is.
So show you it lights up. It likes to light up with me even better, but there's a distance to this, and guys, this is just sand and water. So we see the light lighting up. We know that it's on, right?
Yep.
So,
Oh, wow, you just lowered the frequency hard.
oh, I did.
Yeah.
So it's mud and water. Let's see, I got to reset it. It took it right out of resonance. There it goes.
Nathan,
Yeah.
when you took a handful of sand, when you dropped the sand, it made a super different noise.
Yeah,
Okay.
it made a really
Hold on,
sonic
hold on.
burst.
Take a clump with your hand and then drop it back in.
Yeah, put it in. No, you're gonna have to put the mud back in the water, reset
Okay.
the resonance, turning the light on.
Give me one
Then-
second then. Let me move this because it's right on the edge of resonance. So let me move it into a better resonance. There we go.
So take the
Wow.
mud out, then drop it in.
Okay, hold on. Yeah, it's changing the frequency in my coil hard right now.
Yeah. Now throw the mud in.
You're a big clump.
There it is. Oh my gosh, I know what you're doing.
Well,
It's
elaborate, Gerald. I got a myth.
Wow.
and
You're
when we have-
you're modulating your frequency. Do you know what
Oh,
I
I
mean?
know I am.
So if you were to oh wow. So what this is the transcendental, no, that's the wrong word. Sorry. It's a communication system that will go all the way around the world almost instantaneously. Because what you're doing is you're changing your frequency and modulating it at such a very slight rate. Like you're not taking it out of resonance, but you're just on the edge, right? So you're modulating the frequency and the tone and the pitch and everything's changing. If you were to do that to a voice, you would be literally, you would hear it. Do you know what I mean? I'm not explaining that properly.
You're changing the octave in it or just the frequency? So if you change the octave in a, like I say, opera singer, it would change
More like
the
radio.
sound.
This is like radio. This is the basis of the radio that Tesla found. So you're modulating the frequency in like packets, right? Like FM. You're hitting the frequency and then you have the ability of that wave to modulate it so that you can use it to make voice sounds and you could communicate with it. That's what Tesla found. This is the basis of radio.
Okay, just so you guys know, that was my computer that went off.
Wow.
This energy in this room is getting kind of high.
Oh, you're building it up.
Yeah, I am. And I
Do
keep playing with it and teasing it.
Okay, so do you have a 250 volt 1000 UF capacitor kicking around?
No,
Fill it
I
up.
don't.
Do you have any small capacitors that you can fill up and then short out, make a big pop with?
Oh, no, I don't. I have a capacitor bank, but I don't think I'm getting a pop out of them, Gerald.
You need something small enough that you can fill up, and then when you stick a screwdriver across the post, yeah, you can make that work, but you'd have to put 1,200 volts into that puppy, though.
Yeah, this isn't. I tried it earlier, and it gave me a little spark.
Yeah, you need something bigger than that. See, here's the thing. When the energy builds up in your room to the point where it shuts your computer down, you need to have a small capacitor. You fill it up and you short it out. That instant pop, that impulse, that spark gap of the impulse collapses that energy instantaneously and it goes away.
Hey, quick question, Nathan. Can you create waves in the water as you are lighting the light bulb and checking, making the sounds?
Well, let's see. Let's just turn it on.
Oh, with your hand, like make the waves and see if it changes the sound.
Well, hold on. I'm
Yeah,
just going to lift one corner. Hold on. Does it do anything?
Yeah.
It is, but now make the waves with your hand while the light's lit.
Let's see. It keeps taking me out of resonance when it's doing it.
Oh,
Every time I touch it, my oscilloscope drops a lot.
it's because you're draining the energy into your body.
Yep. Transfer.
Yeah, into the ground, basically. Through your body, not into your body.
It's so interesting, the sounds. It's loud.
Is it? Oh, wow. It's
So now that sounds like a radio station and you're trying to tune it. If you had that modulated to voice, you would literally have radio.
1942 radio.
Yep, absolutely. You got it, Sean.
A tube radio.
It's funny, man, because it's simply, you can see it's sand and water.
So there's
Let's
there's
get this
a
makes a noise.
saying. Well, there's a saying about Tesla. If you do what Tesla did, you will see what Tesla saw. And you're doing that.
So does that make a sound?
Yeah, it changes the sound.
It's squealing, but you're changing the pitch.
Yeah. So you change the pitch with your light load, but you change your tone and your frequency with your hand.
So crazy.
That's awesome.
That'll give you a learning on how this stuff goes. I'll have to turn it up a little bit.
Well, it's the same thing that gave me the idea of popping those capacitors to the song, but I just can't get it. I keep trying.
So my wave here on my oscilloscope, when I do this, it just dances. So let's see if we can't show this.
Nathan, there's a comment saying that live experiments is the best.
Which experiment, yours?
Live experiments are the best.
Sorry, I couldn't hear you. Yeah. Now I wrecked my camera again.
Yeah, you did. It's really blurry.
There's so much energy in here, guys. I don't even know what to tell you.
Oh, there, it's back.
Yeah, it's insane. Turn it all off, set this again. There goes, my camera's back. All right. I didn't have to dance around this time.
Nice.
I did it for you.
Yeah, but it likes metal too. It's not just any, I have baling wire. It likes baling wire. So I can put that right in there. Let's see what we get out of it.
We have some really intelligent people in our chat. Sean, do you want to ask that question that just came up?
from Magneto Frico.
Rico? Yeah.
Gerald, have you fractionated out the colors of the radiant energy yet? Like what a prism does for light? Have you separated radiant into all colored plasmas?
I didn't think anybody would actually pick up on that or even ask that question. So I will say this, or I will do this before I answer that question.
Nice.
That's an applause to you. And I will
Oh.
say, yes, I have. But I'm not going to tell you how as of yet. That's something that's going to come out in the future because it has to do with anti-gravity. It has to do with light, and it has to do with sound. See, that's the next level that we'd be getting into that I haven't really elaborated on. I've been playing with light for the last month. So it's we're there. And let's say this, Sean has one of the spectrums of light that I've been playing with.
Interesting.
Another hint towards what you're working on, Sean.
Yeah, you're like that savant on the piano. You make Mozart look easy, but it's not.
I don't know about the savant, but I certainly feel like the idiot part.
Oh, yeah, I don't think so.
Oh my goodness.
I'm kidding. That was so bad. I apologize, everyone.
No.
Magneto Frico, I will definitely check out your work. Thank you for the heads up.
Right on.
It's a cool channel name too.
Yeah, I like that. Yeah, that's great.
All right, so Nathan, have you measured how many lights you've turned on and then the voltage to make them shine bright? Like, have you taken any measurements like that?
Well, see, okay. So the voltage reads out on your meter, right? Right here. This voltage that comes out of here, I can't get my meter on it to read it. That comes out of the wire side here, right? So I can tell you what I can put into it, but I cannot tell you how much is in it. So how many lights have I lit up? Well, I have 10 of these big ones, and I have this circle one, and they all lit up at 35 volts. And by the way, that's after I took this wire here and I threw it right in this tub of water, and out of the tub of water, they lit up. So water, sand, whatever,
And that's and those 10 bulbs are 40 watts. So that's 400 watts. You're getting power out of that low voltage DC.
Yeah, it's converting it, and it's in like I don't even know if it's in potential form. Gerald could probably answer that better than I can. So,
what did you want me to answer?
Yeah, answer it, please.
Sorry, I was getting asked a question off camera there. You wanted to know about the capacitance of it? I wanted
to know what kind of voltage do you think it is that's coming out of this? Is it potential, or is it something a little different?
No, I believe it's pure potential. I don't think it's voltage at all, although it would convert to voltage with your meter, because your meter, it basically how it measures is voltage differences. So I believe it's pure potential. Like, how would you measure that? If each bulb takes 90, or it takes 10 watts to light, or maybe those are 100-watt bulbs, and
they're 40s.
They're 40-watt bulbs, so they take 40 watts to light, but you're only using 100 watts to light all of those? The math doesn't work. And those are 110 volts, but you're using high voltage on your output in order to create. Like, do you know what I mean?
Yeah, the numbers don't work. It's just a different energy.
It's totally a different energy. think about like an electron that's sitting there bare naked, and everything that sees it just wants to jump on it. But by it doing so, it's creating more energy. I'm not explaining that right. I'm sorry. I got sidetracked with the question off here.
It's all right.
Somebody's talk to me in the background.
So check this out. In this experiment, it's about 30 degrees outside, Fahrenheit. So what I found is when it's light outside, okay, I can't see these bulbs at all. But when it's like this, I can see them just fine, right?
Yeah.
And just like I can't hear the frequency when I'm standing right next to it, but you put it on this mic and you can hear all of it. It's kind of weird. It's kind of spooky.
Yeah, see, and that's wild because I can hear all those sounds when I lower the frequency in my system, but the mic won't pick it up. It cancels it out. I guess it considers it noise cancellation or whatever. So it's different. It's weird how yours is interacting in comparison to mine.
Yeah.
Yeah.
Well, I don't think this mic cancels anything out, is what I think's going on.
Yeah.
There's no
I don't think
noise
it is.
canceling in it.
Oh yeah, really? Yours is just like raw open all the time?
Yeah, so I think that's the difference between you and I and what we're hearing is, well, I can't hear it in person. But then again, I can't hear most things in person. But what I'm saying is there's no noise canceling feature. So like my phone, when I do my regular experiments,
Yep.
there's absolutely zero sound coming from any of this. You can't hear any of it.
Right.
But when this mic's on there and it has, like I said, no noise canceling, you get everything.
That makes sense.
So
Nathan, Ian jumps in. Nathan says that it's difficult to tell about the voltage on the secondary. He says he doesn't have a probe, but he says he has 3,500 volts in the one wire energy using two coils.
nice.
That's awesome, but how does he measure that from which point to which point? I'll have to bug him and pick his brain about that. That's interesting.
Oh, hold on. Let me show you a little bit about what Ian's got going on here. So, and Sean, he's got your work down.
Oh yeah, we go back and forth. He's the coiler Jedi.
Yeah, look at that. He's got what did you call it? Mighty Mini in the center.
I call the coil short stack. He has two of them, but
Yeah.
he's totally done something cool and different with them.
Let's see if I can't zoom in a little more. You can get a.
Did I miss this video? I must have missed this video.
Well, I don't think he came out with a video. He shared the picture with me today, so I wanted to share it.
Oh,
It looks
two
otherworldly.
Tesla coils inverted on each other.
And by the way, Gerald, so you see that little clip he's got on there to hold his coils?
Yeah.
That's what you were asking about that one day.
Say which? Oh, yeah. You're absolutely right. But those are, those two. They're too close together for me, but that's the clip. Yep, that's the clip.
Yeah, you could put it in every other one, I guess. It really wouldn't.
Absolutely, you're right. You're right. I could use that very clip for that and go every other one. Never thought of that.
But that just looks amazing. He said out of two of these, he's getting the 3,000 something volts. Was that what he said?
It seems like that's what he's saying. It's
3,600.
Yes.
Man, that's a lot. So he is close to like over unity on this whole thing, isn't he? With that setup.
Well, it depends on your load, your input and output, right?
Yeah.
Regardless of whether or not you're getting 3,000 volts, because think of a neon sine transformer, right? You plug it in, you can get 10,000 volts, but you plug it into a 110, It's not over unity, but it would make you think that if you don't take into consideration the current. So his load is what's going to define his current pull, I think, because if I understand he's already there, then yeah, I'm betting he's over unity, but it's not the voltage that defines it, right?
So let me ask you this, Gerald. If he took the hot side of that coil and he hooked it in there with the cold side on the other side, acting as the negative, and the other side is the positive going to your capacitor, would it load that capacitor up?
If he went from the hot side to the cold side, it should. But now, what capacitor is he using? Because if he's getting 3.5 thousand, like 3.5 kV, right?
Yeah.
How fast is it going to fill up? Or is it going to just go pop?
I guess you try it and find out, huh?
Right? That's where my head's at with those kind of numbers.
Hey,
Yeah.
Quick interruption, guys. Sorry. So Ian says that the 3.5 kilovolts comes from the end of the rod.
Ooh. Yeah. Nice. Okay.
Nice.
So he's measuring it right from that point. Yeah. Yeah. That's awesome. Now I'd love to see his inputs in comparison to outputs. I'm guessing he has over unity, but it's how much at this point, right?
Mike Faraday said, take a number 1 coil and run it opposite. So normally you run it with the wire winding, the same direction.
Yep.
He says when you wind it opposite, we all know it creates heat in it. It causes that coil to heat. So the question is, it's still broken from the original winding, and it's just a pickup. So could he get more amps out of that?
You know what you just... Okay. So I don't build Tesla coils. You know that.
Yeah.
So you're telling me that your primary runs in the same winding configuration as your secondary? Like if you wind it all to the left, it winds all to the left?
Yes.
Oh.
Or else it won't oscillate.
Tesla was a genius and a dick.
Yeah.
My language. I say that because he knew this. If you wind your primary against your secondary in the opposite direction, you're doubling your output. Your current goes through the roof. Now, maybe he did it the way that everybody's doing it because it was an easier way of controlling your secondary. We wouldn't know that until you do the experiment. But by reversing your primary against your secondary, wow, I'm betting that your power is going to go through the roof on your cold side.
So hold on. You're probably right. But what if we did a radio type thing and we put a floating ground into it and we wind the ground the opposite way? So if I took that primary number 1 and all I do is measure the wire for capacitance by weight, but I wound the bottom part of it that doesn't go over the number 2 winding the opposite way, I'd get heat in that part while the other part oscillates. Can I pull the amps out of that and connect that to the capacitor?
I don't know. That's an interesting question. I don't have an answer for you on that one. I mean, I think you could, but the amount of power, like it would fill up so fast. I don't think you could control it like that. You know what I mean?
If it's based on the amount of winding, so if you put a half wind in it, if it's the opposite direction, how much would it give you? And then if you put a full wind, I mean, we're not talking going the same size as the original coil for the number 1.
No,
I just want to know.
But you're still imparting current instantaneously into your secondary.
Yeah.
Like the way that a Tesla coil works now, from my understanding, when you pulse your primary, it's pulsing a voltage up your secondary, and your secondary is multiplying it.
Okay, but this is what I mean. Take a look at, let me stop sharing this. Take a look at my coil right here. You see the split?
Yeah.
Okay, there's nothing there. So if I wound that opposite wind on here, there's no number 2 coil going down this far. It's all from here and above.
Oh, I see what
So
you're saying.
if I put it under it where it's not affecting it, but it's heating up, as long as I account for the capacitance, I'm wondering if that could be my amps in my circuit.
Perhaps, but I would think more along the lines where it would be at the top of the Tesla coil, wound in reverse, just like your primary, right?
Oh, okay.
But it's at the top of your Tesla coil and wound in the opposite direction.
I'd give that a try.
That would be your third coil. That's your, and it would have to be like a quarter wave.
Oh, like a pulse coil, like
Kinda.
Evo does. Pulse
Kinda.
coil.
Yeah.
Yeah. Okay. Interesting.
Yeah. There's a lot to what you're talking about there, but you and I have to talk off live about certain aspects of what you just brought up, because there's some key safety features you have to go over before you do it. Okay,
Well,
because now you're playing with adding your current into your primary Tesla coil system in order to add more negative or cold energy into your secondary Tesla coil system. You understand what I mean by that?
mm-hmm.
So now you're adding another variant that gets, you could get runaway very easily.
Well,
You know what I mean? I've had problems with mine in the past, so that's why I say that.
I just wonder if I could get a direct transfer then. So let's look at Don Smith and his coils and his direct transfer system. So let me move this. And, oh, just curious about it. So I have a very short one. It's got 3 winds on it. Let me tighten up the winds here. Sorry. Just like I can't get my hand around it right now. All right. So that's backwards of everything, right?
Okay.
So now we'll just run it a little backwards. Let's see what we get out of it. I mean, it may do nothing. It may just do an energy transfer. You know what I mean? It may. I know it's going to conduct energy. I just want to see the heat level on the glass itself. You know what I mean?
Yep.
If it heats up a lot real quick, I know the temperature normally. So let's see what it gets to now. If this thing will stay on there and agree for a little while.
Well, I think what you're going to do there, okay, so I must have misunderstood. I think what you're going to do there is convert the energy into current, but you're going to reduce your energy output like that.
Well, I understand that, but that's okay. Because the cool thing is that tub of water will split it now. It'll allow me to pull one that way while I pull the rest the other way. So it's definitely heating up real good. I may lose my camera. Oh, yeah, now we're getting the heat. Okay.
Wow, that's low tone.
Yeah, it's really low.
Yeah.
Can you hear something?
Yeah.
Loud.
It should be changing the frequency a lot. Oh, wow.
I was just
ET.
whistling so you can hear it.
ET is phoning home.
Yeah, so it's,
That's loud.
It's
I want
so
to say
loud.
this. Sorry. There's definitely more heat there than normal. So hold on.
Yeah, remember, you're converting that energy now. What's it going to do to your environment? Keep that in mind.
May not want to run it that way. All right. Well, that's what testing's about, isn't it?
Absolutely.
I like the sound it makes. It's really cool, like sci-fi.
So hold on. Let's see. Since I have it in this configuration, let's just unhook this. We're going to just stuff it in the hole. Let's line it up.
Hey, Nathan, read the private chat when you get a chance.
Read the chat.
The private chat.
Okay. Is it changing now at all?
Not the sound, but the bulb's really bright.
No sound.
No sound, huh? Interesting.
Very, yeah. There we go.
Yeah, a little bit, eh? Really high
A little
pitch.
bit, yeah.
It's when I get right there. Yeah, look at how bright it is. I don't know if you can tell the difference there. Like that's the. It's like on this side, it's super bright.
I got to dip out for like 2 minutes. I got to go move the car from the street. They're doing snow removal. So I'll be right back, guys.
Yeah, no problem. Interesting. All right, guys, is there an experiment you want me to try while we're playing with this live?
I've been combing the comments. Everybody's enjoying what you're doing, Nathan. But there is a question for Ben. So Ben, do you have an update on the rodent coil?
And the rodent coil.
That's how it's spelled. Sorry.
We call it the rodent coil.
I thought I'd poke fun. Someone said rodent coil.
Yeah, it's funny. So no significant updates. I do actually. Here, give me 1 second. My camera works. Let's see if it'll work. Oh, there we go. Okay, so I just finished the Vortex Micro. As you can see, it's very small.
Awesome.
I only had enough wire to do the single pattern. I don't have the interference pattern. It's only 6 wires instead of 24 for the big coil. But it is going to be going inside the green machine. This is probably going to be a little bit bigger. But we're going to put one of these inside the green machine to have like an all-in-one system. But that's the only update I have for you guys. I'm still testing the Lightning Thief, and we're still tuning it, and we're still working on getting those prototypes out to you guys, out to the team to test.
Awesome. That mini rodent. What are the specs on it?
So the mini coil is 2.5 inches outer diameter to 0.5 inches inner diameter. So it's got a different ratio than the Mark I Dragon 7 coil, which is 6 inches to 3 inches. Mm-hmm. So it's instead of a 1-to-2 ratio, it's more of a what would that be, like 1-to-4, something like that, 1-to-5.
Yeah, that sounds right.
Yeah, so it's quite a bit smaller on the inside, you can see, and that's what you want. You want that to be kind of more condensed. But we'll see. Without the interference pattern, it might not be a good rotary, but we're going to test it on the Lightning Thief and see what kind of results we get. Yeah.
It's a work of art and science.
Thank you. Yeah, hopefully we're going to have one of these puppies inside the green machine for it and just, have that working as a one single unit.
Sounds good. Thanks for the update.
Yeah, no problem. That's all I got.
So just a bunch of love in the chat for you, Ben.
And thank you. Yeah.
Hey, Sean, just try to hover over the comments and click on it and see if it goes up.
Hover over the say again?
Take your mouse and hover it over the comments and see if you can click it.
Okay. I can't.
You can't?
No.
All right, I'll have to fix that then. All right.
Okay. All right. So let's see here. There's a question from Ulysses. Was there an increase or differential in the magnetic field?
So are you referring to the micro here? If he's referring to the micro, there is going to be a significant decrease in the magnetic field simply because we're not doing the interference pattern on this one. I didn't have enough wire to, but it's got enough space to, which is good. So I'll keep it at 6 wires and we could do the interference pattern on the next one. But this is going to significantly reduce your magnetic rotary capabilities. Just FYI, having one pattern. And Michel Morel did some testing, and thanks to him, we do know that conclusively it is going to reduce your potential efficiency.
Awesome. You had mentioned in one of your presentations, Ben, where you were going to look into converting that mechanical energy where the sphere magnet rotates or circles inside of the center of one of your rotating coils. You want to share some info about that?
So that's actually part of what the green machine is going to be capable of doing, and this is a pulse machine. So along with the coil that's going to be on the inside, we'll have like a plate that you can kind of have your rotary above. So it'll produce that rotary effect for something you put on top of it. And specifically, what I'm going to be doing with this is trying to reduce the input power consumption. But not only that, we can also attach maybe like a motor or a generator, small like little motor to generate electricity. It would reduce the RPMs, but we could generate more electricity that way. We also can pulse it at a specific frequency to induce the wireless energy as well. So there's a lot of options here. And what we can, and so this is primarily going to be the pulse circuit design for testing, for you guys to test, and not only that, but to use for your own ends. So
awesome.
Ideally the end result is going to have this LCD display, RPMs for a magnetic rotary that I could develop potentially in the future. But not only that, like we're definitely going to have a Wattman basically set up where you can monitor the input output current and voltage. So that'll allow you to gauge the efficiency. And when you spin your magnetic rotary, you can, kind of see like in this all-in-one system, everything there, all the data. We're going to have a couple of cool features for it. Nothing too fancy. Probably replace this big switch with like a button or something. For the Lightning Thief, I am also going to solder in 2 banana inputs for you guys to plug in your multimeter, because when you right, so the idea of the Lightning Thief is not just a lighting system, but it's also a way of tuning your coil. So and able to find that resonance real easy. So what you can do is just adjust it with the potentiometer. And once you have that resonance range, we want you to be able to plug in your multimeter at the bottom of the device and get the reading of ohms, so that if you want to go ahead and open it up and replace it with the resistor on the circuit board, which we do have the circuit boards coming in soon, you'll be able to do that. So we have the circuit boards coming in for the Lightning Thief and the Green Machine. I'm not sure when the Green Machine will be ready for you guys, but the Lightning Thief hopefully will be ready in a few months to ship out. For I'll probably have like 5 at first to ship out to you guys.
Awesome. Yeah. Hey, also to send me the cost of shipping and parts and labor. I'd be glad to purchase mine and join the club. I know you're not asking for anything. It'd just be more of a donation to the cause.
That would really help out, because that stuff adds up. But I definitely want to get you guys hands-on with some of these devices that we're developing, because they're real fun. And to be honest, I think you guys are going to take this and you're going to just have fun with it and have some interesting stuff that you can add on to it. But and we're my idea is to make it really easy to swap out the components. like if you blow a transistor or a resistor, we want it to be able to be easily swapped out, you know, where you don't have to solder anything. So I'm
Nice.
looking into maybe, yeah, I'm looking into maybe putting in like a like one of those block terminals where you can just slide in the transistor and maybe your neon lamp or whatever.
That's awesome. Sounds
Nice.
like good progress. Yeah, great.
Yeah,
Real
it's coming
quick, you're
along.
talking about stats. If you look into battery chargers on Amazon, the little tiny ones, they give you watt hours. They graph and chart current usage, voltage trends, and they're pretty inexpensive. I don't know. It's weird because I wanted a really good meter for one of the projects I'm working on to tell me all the stats, power, volts,
Right.
and I had to get a little battery charger.
Oh,
And
interesting.
yeah, so just an interesting thing I found.
Because I did find these little tiny mini boards. They're like mini circuit boards that monitor input and output current and voltage or whatever. So they're
Mhm.
basically like, you know, mini boards that you can input. But whatever I could find that's small at this point, because right now the coil is going to make the device a little bit bigger. I'm going to have to do adjustments on the case. I might have to consult with some of you guys on how to redesign this case to get it to fit the components a little better.
Sure.
But that's more down. Yeah, that's more down the line. Right now, I'm focusing on testing and developing the Lightning Thief, tuning it, seeing what it's good for. And I've been using it honestly every day. I don't really use my regular lights too often now, especially at
Wow.
night. Yeah, I just have two coils hooked up, two Lightning Thief devices hooked up together, and it's enough light for me at night. So it's not overwhelmingly bright. And if I want to have it, you know, 100%, I could just unplug it now. I have like a whole setup where I can just plug it in. It's very easy, very safe. There's no exposed wires anymore.
That is so next level when you take your creation and say, hey, it actually meets a need. And I'm using it right now. It has a purpose in my home. So people don't
Mhm.
look at it as just some invention, but they're actually saying, oh my goodness, I can have that in my home. And you can talk about that experience. That's great.
Yeah, and as of right now, I don't know what kind of cost savings we are going to expect with our new energy bill or whatever. But you know, at this point, even if we save $5, that is a win for me because it
Sure.
means that the system that I've put in place is working to some extent. And I just have to, you know, tune it a little bit better, maybe to get it to be a little bit more efficient. What I ideally want to have is a system that just, you know, like a Bedini system, like Gerald said, where you just have one battery charging the other, and you know, you can just close that circuit and have it run indefinitely. Not power a lot, but maybe just a small lamp or a light. Just keep it on,
Sure.
you know.
That's great. And then you can say down the road, hey, it's been 6 months since I've purchased a light bulb or turned on my lamps.
That's exactly what I aim to do. I mean, I know Daniel Nunez took these devices and made them very efficient, but he never actually successfully closed the loop, at least not that he showed publicly and what I could find. And
Mhm.
that's what I intend to do is close the loop, you know, show people that it's possible.
Mhm.
It's, you know, not going to be anything significant. Like you're not going to be able to power your house with it. It's not going to replace anything, but it will, you know, help you save a little bit of money, you know, in an emergency situation or, you know, save a little bit money on lighting. So, I mean, that's really the goal here is just to save a little bit money on energy costs and, you know, do it in
And
style.
yeah, and if you can say, hey, at this size, it realizes this cost, and then maybe you can scale it up. Say, hey, this size
Mm.
here, it saves this cost, and that's you're at the right place, though. I think starting out, you're getting some love in the chat. Ben Vortex says
Oh,
he's proud
thanks,
of
guys.
There's
you.
a question out there. How many RPMs
Oh,
does your
wow.
bearing go or your
So,
tube?
yeah, so I have a tachyometer now.
Okay.
And maybe next stream, like this Friday, next Free Energy Friday, if you guys remind me, because I forget all the time, but I'll do like another, you know, live test or whatever of it, and I'll monitor it with the tachyometer. But last time I monitored it, And granted, this isn't the most expensive tachyometer. It's very cheap, so it might be inaccurate. But it measured around 70,000 RPM.
Wow. Oh my
That's
goodness.
it.
That's
Yeah,
a lot.
it is a lot. And to be honest, the sphere was spinning scarily fast. It was very frightening how fast it was spinning.
You need to have a face shield for that. Oh my goodness.
Yes, you almost do, because if it starts spinning any faster, if I get it to spin any faster, it will start chipping the glass if it bounces around enough. You know, like I have a small shock glass that I've been using that usually helps mitigate the bouncing, which is good to mitigate that bouncing. But if it starts bouncing, it could chip, and if it could chip, it could throw that in your face or whatever. It's dangerous.
Oh my goodness. That's incredible.
Mm-hmm.
Well, thank you, Ben. So Nathan, it's 7 o'clock, Chicago time.
Chicago, little Chicago.
Hey.
Hey,
All right,
But
Sean.
great
Thank you for
time.
presenting today. I appreciate it.
Means a lot, guys. I really appreciate all the love in the chat. Great questions, great comments, and Nathan, our fearless leader, another great video tonight. So I'm gonna head out and talk to you guys soon.
you rock, Sean. Good work.
Right on.
Thank
Thank you,
Yeah,
Sean.
amazing work.
Appreciate it. Bye, guys.
Bye.
All right, guys. Gerald, we haven't talked to you in a while, man. What's going on?
Yeah, give us some updates, buddy.
Well, first you take it and you put it inside out, you flip it upside down, and there you go.
Yeah.
Okay,
That's
I
it.
finally get it.
That's all I got.
You take the thingamabob and you put it into whatchamacallit and
Yeah, you know, the thing I'm gonna do Mahiki. Yeah,
Yeah.
you know.
Oh, it's so great.
You know what? If my camera was operable, I would show you the scooter. See, so there's the camera.
Yeah.
So, but I have the scooter running now, where it's like the alternator is running the back motor and it's charging the battery bank. And when the first primary battery bank gets low, a relay switch automatically flips to the secondary battery bank, and the primary battery bank charges. So you never have to stop driving. I'll be testing
Gerald,
it this spring.
you have to
Nice.
teach me. You have to teach me, because I'm really a desperate need of a scooter, you know, right now to get around.
Absolutely. I'm giving that one out. No issues, for free. I'll do a circuit on it.
Oh, nice.
And I'll give it out on Friday.
Could you maybe give me a heads up on like what materials I might need? I know I have a lot of stuff already, but maybe like the alternator I probably would need. And
Yeah, you know what? The
whatever
best
else.
alternator, honestly, is off of Amazon. It's a GM 110 amp one wire alternator, and it works awesomely. I'll show you exactly what to take out of it. You're not rewiring it, but you do have to modify it a bit. And once you do, it's you're laughing.
I will.
It turns into a 3-phase motor, eh?
Nice.
Yeah, I'm gonna be very excited to learn and actually start to build that one, because again, phase 3 testing has changed a little bit, but that's our end result. We want a scooter, and whether it has a rodent coil powering it or just, you know, aesthetically, you know, starting the system, I think that's gonna be really cool. I'll definitely have to paint it green.
Yeah. Well, the ones that I order are chrome, so
Oh,
they look
that's
pretty,
gonna be
right?
Yeah, like cyberpunk.
Yeah, and I got my alternator generator running. There's 3 alternators on one treadmill motor, so I'm producing like 3,600 watts for a 1,200 watt input.
That's a lot of watts, man. What's
Yeah,
up with that?
I don't know what's going on. You know what I'm saying?
Yeah. Hey.
But those are all modified alternators, not majorly. Like, I haven't changed the wiring, but what I did do is take out the voltage regulators and attach my input directly to the brushes, so I control the amount of power that goes into the alternator. So when you turn the current on regularly, your treadmill motor would slow right down. Now, this is the generator that I built. But because I control the alternator's input, I'm able to turn it up slowly and able to inch out all those watts till I get to maximum power. And then I'm running at like 3,600 watts for a 1,200 watt input. It's like the Malcolm Bendall generator, except there's no gas. It's an electrical input for an electrical output.
That's
You know what I
awesome.
mean? Yeah.
So
Go ahead.
when you modify the alternator, do you have to do? I'm assuming you might have to do some soldering or desoldering there.
Nope. All you have to do is
No?
open it up and take out the voltage regulator. It's 3 bolts. And you take it out, and then you put the other piece back in, bolt it back into the alternator, and you take your 2 wires, and you could actually strip the insulation and just wrap them around there's like little steel posts that come and connect to the brushes, and you could wrap them around that without soldering and run your line out. It's better to solder. It's always better to solder. But if you can't, you don't really have to. And then you use a small voltage regulator to add that input to the alternator.
Exactly. No, that's good. Yeah. Ideally, you're right. Ideally, you want to solder, unless you want like something like I was talking about earlier. You want easily swappable, but that even comes with its downsides. You know what I mean?
Yeah.
So you have to weigh that choice as in the context of what you're doing, I guess. But this is really cool. I'm really excited about your scooter project. It's something that I've been like kind of like geeking out about in the background here for a while now. And
there's a few people that have tried to do it, but they took a different route than I did. And I don't know, maybe I fluked it off, I guess. But I
would trust your method specifically because it's not using, like, we've seen the scooter running on hydrogen, like on water and stuff like that. But yours is basically closing a loop where you're demonstrating something very significant, and at the same time, it's very practical.
Yeah, exactly. And you do have to carry 2 battery banks. Okay.
Right. So right. And that makes sense though. I would expect that.
Yeah, and that's sort of a downfall of what most people would say. They'd be like, "Oh, 2 battery banks, you defeat the purpose." Well, not really.
It makes it a little heavier or whatever, but
exactly. But now the way that I set up my scooter, you don't have to do this with every setup. But my scooter has a small trailer on the back. And the batteries are built like a first level, and then I have like a box on top that I can use to store stuff. So those
you have to send me pictures so I can get an idea.
I definitely will. In fact, I'll do I'll end up releasing the build video on the trailer soon.
Nice.
But I'm trying to put the scooter out first, and then I'll do the trailer. It's kind of one after the other sort of thing. But the fact that you're running your primary battery bank, and while you're running it, because you're moving forward, of course, you're charging your secondary battery bank. And as soon as your secondary is full, your primary won't even be drained by the time your secondary is full. So a heat element turns on so that you can keep using that power. Then when the primary turns like it's dead, it flips with a relay switch, and you're running off your secondary battery bank, and your primary battery bank's getting charged.
So what would you say your hardest or your most difficult challenge was doing this project?
Looking for off-the-shelf parts that anybody could buy so anybody could build this.
So as materials requirements were kind of the constriction there, rather than, stuff like closing the loop or getting it to, actually generate a significant amount of energy.
Well, closing the loop, I kind of learned through doing the other systems, but at the same time, I wanted to make it so that I could give the schematic and the parts list, and you could go to Canadian Tire or wherever it is that you buy your stuff, right? Radio Shack, whatever. And even an auto wrecker actually would have 90% of the stuff you need.
Yeah.
We won't have to like go searching for it, like scavenger hunt.
Exactly. And then put it together. And that was my intention for the scooter, was so that everybody can build it. Then they can't say, "Oh, well, you need a Tesla car and you got to charge it and you got to have $10,000 install in your house." And No. You can run a system that runs itself, but you have to be a little bit innovative. That's all. That's the only difference. So the scooter,
That's
yeah, I
awesome.
won't give that out for free. If it was up to me, everybody had the plans in their back pocket everywhere, right? But yeah, no, I'll get that out to you as soon as possible.
Nice.
Yeah, that's awesome. That's really gonna help my situation out a lot. Yeah.
Yeah, the idea is to actually ride out to Bernie's in the spring. I was going to do it this last year, but the batteries that I had died, and I wasn't working at the time, so I couldn't buy the battery bank I needed.
Joe said Radio Shack, man. Don't bring up Radio Shack. That depresses me. I really miss that place.
Oh, Joe.
No, seriously though, Radio Shack was so convenient. They had everything there. If you
I
needed
love
to
Radio
order a
Shack.
transistor, they got
Yeah.
you, you know, all
Yeah.
that stuff.
Yeah, no kidding, huh?
They were the first place to come out with those realistic walkie-talkies that would go 2.5 miles.
Oh
We
yeah.
figured out a way of extending it to like 5. So we had fun
Really?
with those. Yeah, I
That's
loved
cool.
Radio Shack. It was a fun little place.
Oh man, always modifying something, huh?
Yeah. You know, got to jerry rig it. I don't know if you pick up on that. Jerry's another name for Gerald.
Oh yeah.
Sure he
Gerald
is.
rigging.
Jerry, yeah.
Jerry Lee Lewis, or
There you go. Goodness gracious, great balls of fire.
That's what we can call your device, the jerry rig.
so
Wow.
Rodent is the primary of my Tesla coil. I don't know.
I should show you something a friend made for me. You just said it's
Might
actually
work. I'll
called
try it.
the Jerry rig mag or something like that. I gotta show you it. It's funny.
That's cool.
Anyway, what was that you said, Nathan? Sorry.
Well, he wanted me to put my Rodent coil as my primary on my Tesla coil. The
Does that
conflict,
even work?
like it would work if I did it with the one wire, but would it work if you did it with regular Tesla coil circuit, a ZVS or a Slayer exciter? I think I may have to modify and go to Gerald's cold energy circuit to do it.
Yeah, I don't think you could use Rodent as a primary.
See, that's what I think.
There's a lot of
too. It's
cross
just an
fields.
instinct I have. You might not be able to do it. Like the rodent coil just operates differently. So I don't know. Maybe I'm wrong.
Well, I'll give it a shot.
It's got a different vortex to it. It's a surface wave vortex rather than an actual solenoid that builds the vortex upon the second solenoid once you use the cold energy.
Well, maybe testing it anyways will yield some interesting results. So you never know.
Give us an idea.
Oh, wait until we get to the third level.
Oh, fun.
Then you're talking crystals. You're talking sound. You're talking energy from the spirit. And you're talking anti-gravity.
Yeah, baby.
100% anti-gravity.
I need some anti-gravity right now because I'm getting fat.
Oh, you are.
Not meant to make you more bubbly, okay?
Let me tell you, standing behind that table over there, man, you get to see exactly how fat you are compared to sitting in the chair.
Oh, yeah.
Black was not slimming today for me.
I hear you. Sitting in the chair, I look like a Greek god. I stand up, I look like a pear.
Oh,
Boris said, "Weight, not gravity." Ben, yeah, tell that to my confidence.
yeah.
I'm kidding, man. You know I'm kidding.
You know the old joke, right? Muscles have memory. Well, my ass has Alzheimer's. So we are. I'm kidding.
Oh,
Yeah, so it's been interesting. The last month I've been doing a lot of experimenting. I have the sphere that I want to show off, but I'm a little apprehensive to do it because of what I've been seeing with it.
nice.
Yeah, it gives a whole new level to the idea of drones. And I'll just say that.
Ho, ho, ho. Well, Christmas came early, folks.
Yeah, we're talking some crazy energy. Energy is like not what people think it is. You can turn light into mass and play with it. Like
Hey, you don't want to end up on Santa's naughty list this year, guys. Play nice. Play nice.
Yeah. People see, that's the thing though, right? This technology and what we're using, Bob Grenier calls it God's toolbox. Well, I'll tell you guys outright, it was given to me by Jesus Christ, so you could call it that.
Yeah.
Toolbox, yeah. I mean, Bob Grenier is doing good work explaining what the after effects of these systems are.
Yeah. And next time you see Jesus, let him know I love his work too.
Yeah, right.
I'm trying to contact him, but he don't talk to me.
Hey, actually, he does. You want to know how it starts? You really want to know how it starts? It's like that gut feeling. You know, when you're walking down a street that's middle of the night and you're passing by a back alley and you're gonna cut through the back alley because the back alley's an easy, quick way to go home. But you get that gut feeling where it's just don't go down there, and you don't, so you go home. But you read next morning in the papers that some guy got stabbed in that back alley at the same time you were supposed to walk by. Well, that's how it starts, man. It's that gut feeling.
I always assumed it was because I was annoying. I'm kidding.
No, that's a headache.
You're right. It's that instinct. You have to
hey, Ben,
follow
that's a headache.
follow the instinct.
Man, he must have me on autocorrect when I play with high voltage because he definitely tried to tell me something there.
Yeah, to stop.
That's what I mean.
Yeah,
He's zapping me.
that's it.
Oh man, I had one day. I don't know if I tripped over my laces on my shoe, but I tripped over something, man, and I went zap, zap, zap all the way down until the whole thing unplugged. Yeah, it was not fun.
I'll tell you, when you were doing that table experiment with the aluminum, I was screaming and hopping off my seat, going, "Stop, dude! What are you doing? You're gonna hurt yourself. Don't do that."
Well, I wouldn't show it if I hadn't done it. You know what I mean?
No, I understand totally. I do. There are some experiments I won't show because it might lead people to go down the wrong road, and unless I explain it properly, they might hurt themselves, and that's not what I'm in this to do. I want people to understand how it works because it's coming out. Like, I'll say this: governments of the world have tried to claim it, and one group in particular has tried to claim it for over 1,000 years. And they've kept it hidden, and they choose who they want to allow it to come out.
Right.
So we're probably going to lose viewers when I say these words. And I apologize for that. But the Freemasons keeping secrets from the public are just as bad as those that have been making these systems.
I agree. 100%. I agree.
For their own benefit.
No, secret societies don't benefit anybody. Not the majority of people who need, like this information.
I've known people in secret societies, a handshake and a wink, man, and they get millions of dollars of contracts. Meanwhile, the guy who worked his whole life, who actually deserves the doesn't get it because he's not part of their little crew.
He's not in the inner circle. He's not in the inner circle. I mean, that's unfortunately how it works. Favoritism, it sucks. But
yeah, well, it's mostly amongst Freemasons, and that's why I disagree with their group and their beliefs.
Anybody who agrees to keep information that should be, accessible to everybody, private like that, is, in my opinion, a detriment to the progress of society. You know what I mean?
It really depends on why they're keeping it secret. Now,
well, Nathan, they've had Tesla secrets for over 100 years, and they've kept it secret.
No, that's not what I mean. Like, if you're going through like the Middle Ages, and everybody's dying around you and they're putting people at the stake, I understand keeping a secret there, right?
Yeah, maybe there are variables that we don't see. Maybe
stuff
we're not considering. Who knows?
if it's preserving the knowledge for everybody to get it later, I'm okay with that. But if it's preserving the knowledge to keep people from it, that's a bad thing.
Right. No, that's a good
Preserving-
distinction to make. That's important to make. I think you hit a good point there, Nathan. Because there is a distinction
Unfortunately,
there.
it's been they're preserving the knowledge for their own benefit and outcome, and
Oh, well, that's bad.
wrong. That's
Yeah,
wrong.
the self-interest. Like, I think it has to come from a place of selflessness, you know?
Yeah.
Yeah, I mean-
Go ahead.
There's secrets in these systems that we work with that we don't tell, and because it would just be harmful. So,
Yep.
you know, what I mean,
Yeah,
don't
you ever
even
see
show it. Don't talk
you
about
ever
it.
see the end scene from Raiders of the Lost Ark where they open up the Ark? Just imagine that power. No, it's crazy though, you know?
What we're playing with is 1/1000th of the power that is in the Ark of the Covenant, maybe even 1/1,000,000th, because of how much energy it would take to turn a human being to ash just on the very splash of light upon their body. And that's been written. That happened apparently from the Ark of the Covenant. So
That's a lot of power.
that's a lot of power. And a lot of people talk about the ether on how it's a frequency, it's of magnetics, it's of electrostatics. No, it's a dielectric field. Well, it takes all of those to start the ether pump, but the ether itself has no frequency, it has no magnetic field, it has no electric field, and it has no radio frequency, no radio field at all. It's just pure energy inflow. That's what the ether is. And a lot of people mistake the ether for being something it isn't. Don't get me wrong, you can use plasma in ways where it mimics the ether and even draws some ether in. But plasma isn't ether. Plasma is the catalyst that brings ether in to the system. Does that make sense?
Uh-huh.
Yeah, so in a dielectric capacitor, you would have what they call the dielectric field between the two plates. But I believe there is the plasmatic field, then there's the ether, then the plasmatic field, then the plate. Or what they would say is the dielectric, the ether, the dielectric, the plate. Go ahead.
So I got a question for you. When we say plasma, okay?
Yeah.
I think of it as in high voltage terms. So plasma would be that purple stuff you put out, right? But plasma is a bit different in this field. Wouldn't it be like more like a clear plasma or a...
Okay, so there's different forms of plasma and there's different colors of plasma that are represented by different frequencies of different light spectrums. So plasma's like what Sean's doing. He's producing a violet plasma. That's a very high energy plasma, right?
Right.
Red plasma and blue plasma are totally different energies, but they're still both plasma. Then there's also plasma that you wouldn't see. Like in the coil system the Tesla coil, in between each line of your secondary is something called the dichotron instability, which is basically two plasma sheets that go against each other in opposite directions. Because of the way that the coil is wound and the way that the energy is flowing, you're creating a plasma you don't see. It's a very low level plasma, but it's the flow that creates that plasma in between the lines, the way that energy works. That plasma has no color. It's like invisible. So they consider it ether. It brings in the ether, but it's not. And then when you get into higher level plasmas, like there's red, there's blue, there's yellow, there's green, but green has to do with moisture and fog, and get into that. And then there's red, and then there's purple, right? So all those different plasmas are a different frequency at a different energy level. So somebody had asked in the section, the comment section, if I had seen different colors of plasma in what I do. And yes, I have. I've seen the rainbow. And
Nice.
it freaked the living piss out of me. I won't lie, okay? When you see stuff like this, it's
Yeah.
pretty crazy, okay? But yes, plasma has different colors, different energy levels, and it has different purposes.
Well, I asked because a lot of people throw out the word like a buzzword, but
Yeah.
they have no idea which one they're in.
I know. and they throw plasma out like it's the fifth state of matter. Well, you could call it that, but I don't think the word plasma encompasses the whole fifth state of matter unless you consider the ether the sixth state. I don't know how physicists think in that way. I do know, however, and here's something for you guys to think about. When Moses stood in front of the burning bush and spoke to God, the language that was given to him, Hebrew, were given to him in plasmatic forms that three-dimensionally formed in the air.
Huh.
That is just crazy, insane cool.
Yeah.
Yeah. And I can prove that in the future. I'm not going to say how or when, but I can prove that. Big boast? Heck yeah, I'm going to be bold. I can prove it.
Huh.
Everything
Nice.
I've said in lives and everything that I'm saying, I can prove, or I would not say it. But will I prove it on camera where some dipshit in the wind could go and say, oh, it's a camera trick, he's lying? No, I don't think so. You know, if you want to see it, come to my house. I'll show you. I want to do some form of a seminar or a group gathering, a get together with all our group and everybody else that wants to come and see. And I want to do a demonstration like Tesla did.
Well,
I'm going to show people.
I'll be honest with you, Gerald. I want to come down in the summer, not in your winter.
Yeah, I was just telling Michelle earlier that I literally crossed Disneyland off my list and put Gerald's Workshop of Wonders.
That's right.
That's awesome. We'll get the League of Extraordinary Inventors to come out, right?
Yeah, that's right, because
Oh,
Mike's over there in Canada as well.
Yeah, he's
Nice.
not actually too far from you, a couple hundred miles.
Well, that's better than what I'm at. So, yeah.
In Canada, a couple hundred miles is nothing. Like it's 1,200 miles to the next city, so to speak, right? So
Wow.
big span out. It's not like the States where it's the next state is like what 20 miles away, and then you go to the next state's 40 miles away. You know what I mean? It's huge.
Yeah. Crazy,
But-
man.
If we get enough time, I could even show you where that underground pyramid is in Saskatchewan. You could take a road trip.
Yeah,
Yeah,
well,
Go ahead.
I'm retired, Gerald, so we got the time.
Oh, well, we'll have to work that out then. We'll have to work out the
Yeah.
details for sure. Yeah, absolutely. We can go quadding. Well, I don't know. Can you do quadding with your back?
Oh, yeah.
Yeah.
Look, I do anything. I just pay for it.
Oh, yeah.
Yeah, so
I understand. All right, then. There's lots we're going to do. We'll have fun.
I'm going to be over there in like an ice bath or something. You know what I mean?
Oh, yeah. That's okay. I'll get a hot tub for you.
Yeah. I'm going to have to lose some weight. I
Yeah.
got to slim down.
That's okay. I've been doing that myself too, actually. Need to slim down. Lots of mushroom to go around.
Yeah.
Yeah. Somebody said in the comment section, check that out, eh?
Oh, hold on. Put some shrooms in there. Oh, do you even see that, Gerald? Like in the comment section when you go on like your live chat and stuff?
Yeah.
Like mine shows all the mushrooms, the captains, everything that I put in there.
Nice.
So yeah, it shows everything. So all those little emojis that are at the bottom here.
yeah.
Once you become a member on the channel, man, you just slip them into the chat all the time. Like,
Yeah, you know what? I was thinking about that. I'll get my old lady to do that on her PayPal, and then that way it's all good.
we
'Cause I
put.
can't-
Sorry. I put in there the emoji down there. See it on the bottom right, the holes.
Yeah.
That's the last one I just put in.
Holes.
Yeah.
That's funny. Is
Oh,
it 3 holes though? It's not Canadian if it's not 3 holes, man. Like, come on.
I put 4 holes. I got an extra one. Must have an alien.
Must be European. I shouldn't say.
Oh my God,
You gotta have fun.
you missed a lot of things, Gerald.
Yeah, I know.
You missed the aliens dancing. You missed the last Fringe think tank Star Trek.
Oh no, I caught those. I laughed my ass off, man.
Oh,
I just got them after, right? I didn't get into the live, but I can still watch videos. Just I was having weird. Somebody took over my system because I go to shut videos down and my mouse wouldn't work, and I go to turn videos on and they would shut off right in front of me, and it's like, what's going on, you know? But when you're this close to the mark, I guess they like to target you. So
yeah.
yeah,
They like
whatever.
to troll you a little bit.
Yeah. Let them play their games. Game on.
Come on.
You know what I say to them? That model is not. Look, what is it telling you? You gotta have
Oh,
fun.
yeah.
You gotta have fun.
Yeah, it's a Joe. We're glad you're back. I think all of us feel that way.
Well, I'm as back as I can be for now, anyway.
Well,
I get my camera up and running, it'd be a little better. I'll be able to show more.
yeah, but it's good just to hear from you.
Yeah, I hear you. It's good to have fun on camera, I tell you. I love the laughs. That's what I like to do. If it was up to me, I'd be in my backyard barbecuing and cracking jokes all day long.
Oh yeah. Well,
Yeah.
I'm there with you, man.
Yeah, well, life's short, right? So you got to smile, you got to laugh. Laughing's the best medicine. That's what they say. So, and I wonder why that is, considering laughter brings your mental and your whole body's vibration and frequency up to different levels. So maybe it's an interesting thought.
Yeah.
Is there any questions out there? Because I know you've been going for a while here. I haven't. So
Oh yeah. Well, I'm sure there was in the beginning, man. I was off doing the testing, so I don't know.
right.
I was just excited that I finally got my work table. So I finally got my work table where I can work it and show things to people. So that
Yeah,
they can.
Go ahead.
No, I was just gonna say so they could see exactly what I was talking about and they could ask the question they've been dying to ask.
Yeah, I like that idea, actually. I might mimic your idea. I might steal it from me a little. We'll do some live stuff in the next little while.
So they can finally see all your holes.
Yeah, I got lots of them.
Well, I got it from Papa Bale. He does his pulse motor and he walks around and talks. You know, my favorite line from him is somebody said something nasty in the comment and he told him, he goes, somebody's going to have to go and wash your mouth out with soap. And I fell out my chair right then and there. I've watched his stream ever since.
It's like Captain America in the movie. Hey, language.
Yeah.
They all start making fun of him. He's like, I'm never going to look back down, am I? Nope. Yeah, Papa Bale rocks. I watch him actually quite a bit. When he gets lives, I comment and stuff as much as I can. He does good work. Yep.
Yeah,
See,
he's really good.
I think that's the part that's good work, is like what you just did. You're doing the experiments, you're looking at the comment section or having somebody read the questions, and they're interacting with your experiments. So their ideas get out there as well. That's awesome. I love that format. I think that's going to be something I maybe move into next.
Yeah, well, I'll read the comments if you want. John likes reading the comments too, man. So
yeah, absolutely. That's great. Yeah, because I want to show some new experiments and stuff I've been doing. Although I got to say this, Nathan.
Yeah.
You beat me to like quite a few, okay? There were some things I was going to show. I did a video and I'm like, okay, I'll save this. So I was going to do what we talked about, release them a certain way, right?
Yeah.
And then you did the video, and I'm like, okay, that one's off the list. You did another one, I'm like, that one's off the list. So it's like, it's great where you're going. I wish I could have interacted with you a little better while things are going on, though.
Yeah. Well,
Because then I would have done the videos with you, right? But it's great that you did. I'm happy that it's gotten out there, because people's understanding now has gone so much further. But did you, and this is a question and half of a thought, did
Okay.
you see the latest Martin Fleischmann Memorial Project's attempt at John Hutchinson's replications?
I did.
And you watched all of it?
Yeah.
I'm tempted to do John Hutchinson's replication because of what we understand. They were using Tesla coils. They weren't using them like we use Tesla coils. Do you know what I mean by that?
Yeah.
Did
So-
you talk to Bob at all? No way.
I don't have a personal relationship with Bob. You know,
I've
like
talked a few times.
everyday schmo, I leave my comment and you know what I mean? That's it.
Yeah.
So
Yeah, I agree.
yeah, but I don't know. Some of it wasn't right in the setup at all. And I didn't care for it, but I wish them all the best of luck and I hope they get something to work, but I'm just kind of curious about certain parts of it.
Yeah. Yeah. I watched the whole thing, and I get what they were trying to do. They were trying to force electrons into a nonlinear spin by
Mhm.
using their tubes. It's not quite how it works. In fact, I don't believe that's how it works at all. But I mean,
They
good
look
on.
like beautiful light bulbs, but that was about the extent of that part.
Yeah, yeah. I know where he needs to go. I kind of wish, in a way, that Bob Grenier wasn't working with Hank Uren so much, but I haven't reached out to Bob as much as I did in the beginning. Because in the beginning, I was talking with Bob on lives, and I had reached out to him a couple times, but I hadn't gotten in depth on how my system worked. And as soon as I did my presentation, call it divine providence, call it what you will. But he did one right after that, and it was pretty close to mine. So, like I said, it's, I don't know. He's doing the same work, but differently. I think that he could be getting a lot further, a lot faster if he was listening to us. But maybe that's just a wrong way of thinking of things. You know,
Well-
'cause we're all going about it this different ways.
I think honestly he should call you up and you should spend 2 hours on his show, and I think it would really help him curve some of the ideas and straighten some of it out, and you really get a lot further.
Well, I might have stuck my foot in my mouth with complaining about Freemasons.
Oh,
Because his dad was a high-level Freemason, so I think that might be where my issue is with Bob. I have no issues with Bob. I just think that Freemasons are two-faced, backstabbing slime balls. But that's just my opinion. One man's opinion doesn't matter. It's one man's opinion. Come on. Just saying.
well, who cares? I mean, in the end, I dude, what I don't like is some of the stuff is like high school, bro. Like I'm over that big time. Like,
Yeah.
you know, I don't really have any ill will towards anybody, and I don't think I ever will. You know, I just don't have to roll in those circles anymore. You know, I don't have to be around that. And it doesn't have to get to something where we don't communicate on information like this.
Yeah.
I don't know. Maybe I just see it differently.
Yeah. Cote's got a good point there. They're not all bad, Gerald. You're right. You know what? When it comes to individual people that are Freemasons, there is a few good ones. In fact, I had a friend that was a Freemason that was feeding me a lot of information. So people are people. I get that. But as a group, their whole persona on keeping secrets from the public, and keeping certain things from the public for their own benefit. It just doesn't wash right with me. That's just me. I don't know. Maybe I'm wrong. If I'm wrong, hey, convince me, man. I'll be right there to apologize. You know what I mean? It's just I haven't seen too many good Freemasons, and I said this before. They tried killing my dad twice, well, 3 times. Once I was in the car, and
Wow.
yeah. So I'm not so
May
up
I
on
ask what-
those. Could have been a bad group of guys. You're right. I'll give you that. But
May I
kinda
ask what your father did to piss him off?
Yeah, I'm no problem telling the story. My dad saved 27 miners from a cave-in because there was a group of guys that wanted to grab the gold that was sitting in the Inco mines in Thompson, Manitoba. And the only way they could do it is by burying a lower shaft and going in and sneaking it out. My dad was the cage tend operator, which is the person that's responsible for bringing the elevator down and bringing the people up. He's the responsible guy for all their lives. So he was on break. He'd come back from break. His foreman said that not to go down. They just lit the fuse. And he's like, I got 27 guys down there. And he's like, well, there's nothing we could do. The fuse is lit. So there's an operation in the elevator where you can release the cable because it's like a braking system where you go down slow, right? Well, you can release that cable and just free flow all the way down. They don't recommend it, and you can hit the emergency brakes and then slow the thing down. You're not supposed to do that. Well, my dad, when he heard that the fuse was lit, he dropped the hammer, dropped the elevator 27 stories, slammed on the emergency brakes, grabbed his guys, brought them up to a higher level, put them in a what's called it's a safety area, and then the explosives went off. Because he saved those guys and those guys knew that the gold vein was there, the people that were trying to steal it were foiled. And they were the Freemasons in that town. They tried, and I don't want to get into the first 2 ways that it happened because we don't want to talk about that on this channel, but there's proof that they tried to do it the first 2 times.
Wow.
Physical proof. And the second or the third time when I was in the car, we know who did it because we knew that he was in town at the time. And the 3 nuts on the front tire of his car were cut 3/4 of the way through so that it would look like the tire broke and we just slammed into whatever, right? And we were on the highway that night when the tire blew. What they didn't know is that my dad was an old race car driver and used to do smash up derbies. So he knew what to do when the tire broke off.
Wow.
We're doing literally 50 miles an hour on the highway. And I looked at my dad and said, Dad, our tire just went through the ditch. And he went, fuck off. And I went, I'm serious. There's our tire. And he looked and he seen the tire literally out rolling the car. And it jumped the ditch 10 feet into the air and disappeared. This is in the winter.
Wow.
Okay. And he was able to slow us down and drive us out of it.
Nice. Good.
Mind blowing. So because of that and what he did and saved those lives, it stopped a whole bunch of gold going into the hands of these Freemasons. The story goes, because my dad's friend, like the friend that I had was a Freemason, was my dad's best friend in that town. And he was feeding him information. And he told him exactly what was going on. So that's how I know that they were the ones that were trying to kill him because they wanted revenge for what he did. The gold was apparently worth something like $30 million. This was 20 years ago. Now it's probably worth billions. So take that with a big truck of salt, but that's why I have issues with Freemasons. So, yeah. And that's all been well documented. There's affidavits on my dad's side and the people that were involved. And so it's not like a conspiracy. It's actually, it happened. The police involved and it was a big deal.
Wow.
Anyway, Yeah, and the whole thing behind that, and I researched the Masons. Don't get me wrong. I'm not just like throwing something out there. I know that they swear an oath to harem a biff. I know the procedures that they go through. I know all their secret handshakes. I know the different oaths that they take to get to the different levels. And who cares? That's their game. Let them play it. But when you start taking from the public and making them suffer because you want to get ahead in life, and your brothers in secret are going to help you do that, you cut off the public's ability to do what they are meant to do in life, which is what? If somebody goes to school and trains for 10 years to be an engineer, but you take the contract or that spot because the person that you know is a Freemason and that other one doesn't get the spot, you ruin that guy's life. For what? A handshake and a wink?
Yeah.
I don't agree with that. That's just me, right?
No,
So,
I wouldn't agree to that either.
there's my explanation on Freemasons. I do agree with Cote when he says that not all of them are all bad. You're right. There are a lot of good people that got hornswoggled and tricked into becoming part of that group. But that's just my opinion. So
Okay.
there's a long explanation, Ben. Did that answer your question? Ben
No,
Post,
sorry.
Liberty.
My microphone was muted. No, that answered my question pretty well. And somebody mentioned something in the chat regarding, can I use a top? I'm not really sure what you're referring to. Can I use a top? But anyways, back on topic.
Oh,
That's
like a spinning top, the tire, maybe?
I'm not sure.
Yeah.
But either way, that's an incredible story. And hats off to your father, you know.
Yeah, for driving you out of there and keeping you safe. Yeah.
And also
Yeah, he
having
was-
the courage to stand up to these people. You know what I mean?
You know what? My dad would have took a bullet in the head to stay straight. You know what I mean? To make things right. Like, that's how he was. He'd die for the truth rather than, live on his knees with a lie. That's how he was. You know
He
what I mean?
definitely raised his son good, so I can say that much.
Well, I don't know about that, but hey, I've made my mistakes, dude. I'm so far from perfect. You know what I mean? My dad was my hero, but he was also a dick. He was my dad, right? Well, we can say that because we got to be honest with each other,
People
Like-
aren't just, black or white, like there's shades of people, I could be a dick too. You know what I mean?
Exactly, right? We're all human beings. We make mistakes. We are who we are. But yeah, my dad, for the most part, was my hero.
Yeah.
Yeah. Yeah, because he could have died when he did that to save those people. He didn't even think about it. It wasn't even a question in his mind. I got 27 people down there. I can't have that. And he just did what he had to do, right? To me, that's what defines a hero, is someone who doesn't think about what needs to get done. They get done regardless of the consequences. And
Yeah.
we need more of that these days, everywhere, in every country, all around the world. That's
Great.
just so anyway, that's enough preaching on my end. Sorry, guys. Just telling some stories about my life. That's all. Now that I've bored the audience to death. Yeah, we've been going for what? Now you're at 3 hours.
Yeah, we're about at the end, Gerald. I'm deciding if I wanted to say something or not about somebody else, but I might let it go. It's just, I was on and Mike brought it up in here that Ashton Forbes was doing a show the other day.
Oh yeah. Did you see that? Okay, go ahead.
Yeah, so somebody out there did me dirty, and then somebody did me dirty on top of it. So, yeah, I mean, I don't know what to say about that other than it's just a complete lie. So,
Well, maybe we should talk about it offline, but yeah, that really sucks.
You're going to have to fill me in. I don't think I heard any details on that.
Well, I could say this: what Ashton Forbes was talking about, like the content, he was dead on. Right?
oh, the show was great. Don't get me wrong; it was nothing against him in that.
but
It was he let his buddies smart off on the mouth, and then blocked me for about 30 minutes on that show from telling him what he really was. And I'm not talking about Ashton Forbes, by the way. I'm talking about the other guy.
Yeah, I know who you're talking about.
So
I know exactly who you're talking about.
let me just say that I always try to be the bigger man in the situation, and everybody here knows we don't talk about it. We just kind of put it to the side and let it go. And I don't bring people's names into it, and I don't talk to anybody unless it's one-on-one. And that was the only conversation that was had. Okay, that was it. There was no talking to anybody behind somebody's back. There was no girly talk. I don't even know half the people this guy knows, man. All I could tell you is I had a one-on-one conversation with him and left it right then and there, and that was it. Okay? So there was no more to it than that. And, I think there was some hurtful things done to some other people, but I didn't say those things to those people. So unfortunately, they got caught up in it. And like I said, if I had those things to say to somebody, I would have said them myself, and I would have, talked to them one-on-one about it, and I didn't. So it was just a dirty little punk move. And, you want to play hee-hee-ha-ha behind the scenes. That's fine.
Yeah,
But,
see, I know what you're saying, and that really sucks, because that's the kind of thing that makes me wonder about the manipulation and stuff that's going on behind the scenes when we release information. Because the information that we release is we're not talking theory here. We're not bringing up other people's papers. We're not talking about crap that happened 10 years ago. We're talking about the stuff that we do today in experimentation. See, we're way ahead of half of these guys, and they hate it because they're supposed physicists and learned men who have prestigious paperwork. There's another person that wanted papers too in World War II. You understand what I'm saying?
Yeah, I'm not worried about that, Gerald, to be honest with you.
Well,
they can have all the information. It's free on the channel. I mean, everybody knows that. But
agreed. But at the same time, when they claim it to be their own and then start to play games around it, that's the kind of shit that's really childish. Like,
yeah, I don't. How about this? I didn't want to devolve this into people like that.
Oh, okay. So my bad,
I was yeah, I was directing it at one person, and he knows who he is.
Yeah, that's okay. You can call me a dick. I've been a dick before. It's fine.
He should keep my name out of his mouth, is what he should do. So, yeah.
I can make a really bad joke that would get me in so much trouble right now.
Just dumb. It's just dumb. Yeah. It's childish stuff that somebody did on their own and wants somebody to blame.
Ultimately, it's like jealousy, right? Jealousy kills.
Oh, it's 100% what it is.
Yeah.
Always claiming that they did something that they didn't. That's for sure. Yep. And claiming they should get all the credit but can't show up.
Yep. In organized, when I was a kid and I was in bad stuff, there was a saying about that. Jealousy kills. Jealousy in everything and anything. It kills. It doesn't matter who it's with. If it could be a guy jealous of your work, it could be a girl jealous of your girlfriend, it could be, and somebody who's in some kind of corporation jealous of your work. Jealousy kills. It's brutal. It's evil shit.
Yeah, you don't want to be drinking that haterade. It's
exactly.
It's a toxin. It's
the way I like to see it is, or the way I see it is like, if you've done it first, I'm going to applaud you. Now teach me so I can do it. I want to have a little fun before it's all over. You know what I mean?
Yeah, I mean, look,
that attitude, so.
It could get real ugly, and I do not want it to go that far. I think that person should just shut their mouths and be done with it. And that's what I think, because there is, I mean, what do you say? Like we have something to settle. There's nothing to settle. I mean, that's about the way it works. And dude, I can just pull the copyright on that and yank it right off of there, and then we could settle it. And then you can see, you know what I mean, how much of a, what I could be. But I don't plan to do that, because that's not who I am.
Or
at least not let you push me.
Hey, or they can take a page off of Eddie Murphy's Raw when he says, "You can have a Coke and a smile and shut the fuck up." Just kidding. I'm a dick. I know. I'm sorry.
Hey, I wanted to say real quick, hi Jeremiah. We'll let y'all next time, man, when we do this. I'm sorry, we're kind of getting towards the end here. It's been quite a while.
I think I've drained them.
But if you want to come on next time, man, just let me know. Okay, and we'll have you on and we'll talk and we'll see what's going on.
Yeah, for sure. It's been a while, Jeremiah.
Yeah. So sorry, man. Yeah. I kind of now I'm in the mood. All right.
Just bobulated. I can see it.
Yeah.
Yeah. Just think of that poem from Dylan, right? We will fight against the dying of the light. We will fight, fight. That's what I love. You know what I mean?
Yeah.
So I think it's actually, I don't know, time to close it out or what? We're at the 3
Yeah,
hours.
time to close it out. Hey, I want to tell everybody in the chat, thank you very much. You guys have been really awesome today. I want to say thank you to Jarvis, man. Thank you very much for everything and all the stickers and everything, man. You're really awesome. Go ahead, guys.
Yeah.
Thank you.
Go ahead, Ben.
I was just gonna thank the chat as well. Really appreciate all the love and support, guys.
Yeah, and I love the interaction. The comment section is awesome. When you make me think, I love that. So shout out to Cody. You made me think. That's great. You guys are great. I love this channel. So thank you.
The chat is priceless. It is. It really is. You guys are a bunch of gems.
Yeah, we're all gonna have to do some live demos now.
Oh yeah.
Have some fun. All right, guys. Have a great night. Thank you very much.
Have a good night, everybody.